Short and sweet.
Oh, and this is really easy to use, and you've got a monitor down front.
Okay, perfect.
Okay, well, I think we'll get started again. I'm appreciating all the, meeting all the new people that are here. There's lots of networking happening. This is fantastic. And people have already approached me for new proposal ideas. So I'm going to call us back to order. We have some fun stuff coming up for the next hour and a half or hour and a quarter. So we'll wait another minute. Let me also just mention, it looks like we're on live stream now. So for the speakers coming up, not only just a reminder we're recording, but also I think the live stream is running. So just to note that. All right. Thank you very much. So we're changing the order just a little bit here, as this makes sense. So Dr. Bill Gropp is the PI for the Midwest Big Data Hub. He's here. He's going to talk a little bit about national level data efforts happening on some big scale projects for a few minutes before the panel, and then I'll be back up for the next panel. So Bill Gropp.
Thank you, Melissa. I want to say first, I want to offer my welcome. It's really great to see all of you here and to hear about the things that are going on. This is particularly special for me because CASE is my alma mater. So it's been fun to come back to campus and see how much has changed, and because it's been a while since I've been back. I'll also say the brew pub in this building is really good, and that is something that we didn't have when I was here before. So I wanted to say a little bit about what my organization at Illinois, NCSA, is doing, partly because many people think of NCSA as a supercomputing center, which it really isn't. It did start that way, but that's not what it is, and it's not what it does. It's a component of our activities, but in fact, it's not even the biggest thing that we do. So organizationally, we're one of 8 campus-level interdisciplinary research institutes. My boss is the Vice Chancellor for Research. We're the oldest interdisciplinary institute on campus. There's a little asterisk because another institute, the Prairie Research Institute, is made up of the state surveys, some of which predate the university itself, but that organization is only about 10 years old. And I think maybe the clearest way to look at us is what our mission is, and our mission is to bring people and resources together to solve really big problems in advanced computing and data. And honestly, I added that "and data" because when I think of advanced computing, data is so intertwined in that to me, it goes without saying, but not everybody agrees, so I always add the "and data." We have a lot of activities. So we run the Blue Waters Leadership Computing System, so that's NSF's only leadership computing system. We're also the data facility for the Large Synoptic Survey Telescope. I'll say a little bit more about that because that's a great example of both our long-term commitment to data science and an example of some of the data science at scale that's going on internationally. We also host Exceed, which is a virtual organization that supports the NSF supercomputing centers. We have lots of other smaller projects, of which I view the Midwest Big Data Hub as an important one. Other data-centric projects like the Dark Energy Survey and so forth. We do a lot of work with industry. We have perhaps the largest HPC academic industry program with partners both in the US and internationally. We do a lot of work in software for data management and data analytics. I'll say a little bit more about that and you'll hear more later today. But that includes, for example, visualizations to convey science to the public. If you've seen IMAX movies like the Hubble IMAX movie or Beautiful Planet, how many people have seen one of those? So the rest of you should go out and see them. In the Hubble IMAX movie, the flight through the Orion Nebula was done by Donna Cox and her group at NCSA. And we have a lot of interdisciplinary projects with faculty on campus. We do Sea grants, we do a lot of support for this, and we host things like the Illinois Data Science Initiative, our Computational Science and Engineering program. We have a deep learning major research infrastructure award from NSF, which is supporting researchers across campus and so forth. In data science in particular, we build systems to solve problems in data science, and that investment started literally decades ago. Our second director, Dan Reed, really started investing in what's now called survey astronomy, which is really transforming the whole field, not just in terms of the amount of data that you can get, but with the Large Synoptic Survey Telescope, we'll be adding a time dimension to the data that astronomers have in a way that they've never been able to do before. We have a number of strong visualization groups, and in particular, this is a place where I think we have really great connections with the missions of the hubs, is we really look at the way we approach these problems is partnering to build communities to solve problems and to support data science. So we have strong efforts, as I mentioned, with campus, regionally with the Midwest Big Data Hub and other activities, nationally through things like the National Data Service and the Open Storage Network, which you'll also hear a little bit more about, in fact, right in the session after I finish giving you this little intro. And internationally, we work with organizations such as the Cypress Institute, where we've helped develop a new primary source in medieval studies by using advanced computing to extract graffiti scratched into stone in churches, as well as at a high end, so for example, for the Joint Lab for Extreme Scale Computing. Just a little bit on the Large Synoptic Survey Telescope. This is a large by most standards, so it's an 8-meter telescope. There are some 30-meter telescopes being constructed, so large is in the eye of the beholder, but this is twice as large as the biggest telescope in the world when I was growing up, with a 3 gigapixel camera, which will produce a survey of all the sky that's visible from the mountaintop in Chile where this telescope is being assembled, and it will do that every 3 nights. So you continue to resurvey the sky so that you can see what's changing. That's what I meant by adding a time dimension to the practice of astronomy, which really has not been possible in the past. And the amount of data will be about 15 terabytes per night. That will come up to NCSA, we'll reprocess it. Part of that processing is detecting those changes and notifying subscribed astronomers within a minute of the image being taken down in Chile. So this is a challenging but very exciting project. We're really happy to be part of this, and it is an outgrowth of our long investment in data science and survey astronomy. We also do a lot of work in building solutions, whether these are software or hardware or mixes of these, and I'll just mention one of them in terms of software, and again, you'll hear, I think there's a poster this afternoon, you can see a little bit more. This is a tool called Clouder, which addresses in part the variety and the many V's of big data, and as an example of this sort of community that we've been able to build around it, this gives you a nice little picture both of the domain areas and the partners that we've been working with on this. And so with that, just want to, again, take this opportunity to tell you a little bit more about what NCSA is and what we do and how it relates to data. Very happy again to see all of you here to talk about the progress and the directions of the Midwest Big Data Hub. And with that, I will turn it back over to Melissa to start the panel. Thank you.
Okay, so this next panel includes a set of people that are working on or leading initiatives related to the Midwest Big Data Hub or all of the big data hubs in some way. And so what I'd like to do is actually invite the panelists up, I think one at a time, to do your talks, and then we'll fill the panel up as you come up. So it's Lior's first, so Lior, if you could come on up, that would be great. Thank you. Thank you very much. Welcome back.
Okay, so one of the missions of the big data hubs and other activities is to define big data or data science as a discipline to facilitate research activities, education, workforce development, and so on. But in most of the discussion, most of the activities are really focused on from the perspective of large research institutions. Now we have to remember that large research institutions train about 15% of the national IT workforce. 85%, the vast majority of the IT workforce is trained in community colleges, liberal arts colleges, regional campuses, tribal colleges, HBCUs, so on. So it happens that the vast majority of the students actually are kind of excluded from the discussions. Now, more importantly, is that those 15% that I just mentioned, that's not a random sample of the population. Those are the most privileged populations of the country, those 15%. And those 50% don't represent or don't fully represent less privileged populations, such as students of color, first-generation college students, working students, part-time students, commute students. Those students, these are the students that need the intervention the most, and those students are served by those 85% of those the institutions that I just mentioned. So they're not being exposed. They don't have access to all these activities that we do here. So that you have to see a problem here, and that's the problem that we're trying to solve, how to serve those institutions, how to serve those 85% of the students, 85% of the least privileged students normally. So for that, we established a group that we started. We've been working for almost a year and a half, and we include the perspectives of all kind of different institutions, not just the large research institutions, but also tribal colleges, HBCUs, liberal colleges, and so on, all of those institutions to have the different perspectives. And we have a group, I don't know if you can read it from there, but we have a growing group of people that brings those perspectives, these different ideas, different needs, different gaps that need to be closed, and that might be different from the reality of the R1 institutions. We have some activities that we're doing. So 23 institutions so far and counting. We have some virtual communication that we're doing over the past year and a half or so through virtual communication. We have physical communication. We had 3 meetings so far. The last one was here yesterday. We had in the spring we had a 2-day meeting, a much longer meeting. We could exchange a lot of information. That's from the meeting that we had in the Big Ten Conference Center in March. It's a pretty interesting meeting because you get a lot of different perspectives on data science, what data science is, how to do it, what the gaps are. You're getting a lot of information, a lot of exchange of information. And I compare it to I don't know if you attend the NSF-PI meetings. I go there once a year. And it's kind of one-dimensional. I kind of know what I'm going to get there before I'm getting there. And those meetings are much more diverse, much more broad, and more ideas that we can learn. I kind of recommend even joining the thing just to see what's going on, just to see what's out there. It's pretty interesting. And we defined several of the challenges. We prioritize them. So the challenges, the gaps we define for each challenge, for each topic we define the gaps, how we close the gaps. We have some plans and some activities. We're not going to do everything all of a sudden. It's going to be a process, but we have to start somewhere, and we already started, and we're moving forward on that. And that's that's something that came from the first meeting that we had in Omaha, and I think that a quote by Carl Schmitt I just learned. But that's one of the things, not to make the same mistake, to identify those mistakes in computer science statistics as we develop data science as a discipline, as a standalone discipline, to identify those mistakes and learn from those mistakes, not to repeat them again. And we have a lot of, we kind of broke it down to things that we need to do to avoid that. Now, research is also an interesting point here, because data science is not the kind of the standard standalone discipline, traditional discipline. Data science is a discipline that lives mostly in the context of other fields. And that makes it tricky to, when you try to force data science onto the 9-year-old bureaucracy that we have in academia, then that leads to a lot of anomalies and lots of confusion. Not everything works so smooth when we try to do that. And that also applies to research. Many things, let's say, fall between departments. Many things fall between NSF divisions. So it's not so smooth, and you can see that many of the people who define themselves as data scientists, for instance, are not exactly data scientists. There is a computational scientist or other things, but not exactly data science. So the whole definition of data science is really affected by that bureaucracy that we have. It really reflects on it. And until just recently, we didn't, there were barely even career path for computational, for data scientists. Many of them went to smaller school, developed their expertise there. Now they have that expertise. The question is how we can combine, how we can use that expertise for research. It might seem, the idea might seem weird at first that non-research institutions give research services to research institutions. It might seem a little bit weird, but if you take a deep look into data science as a broad discipline, it starts to look much less weird. It starts to make much more sense. You see all those pockets of nice data science research that develops in actually non-research institutions because they had the time to develop that. And for the future plan, we worked until now on a planning grant. Now we plan to continue these activities by another round of funding, hopefully from the NSF. We're working on that right now. I'm not going to get to all the details, but we broke it down to specific activities. So each challenge is now supported by specific activities that we think we should be doing, we should be working on. It's not going to happen in 1 year. We know that. We need to, beside all the complications that data science introduced as a discipline, as a non-standard discipline, there's also the very solid views of what data science should be that we need to deal with that too. So it's going to be a process, but we started that process. We're going to do it in the next, now we're working on developing a proposal for that. Due is just, as Melissa mentioned, is mid-January, and hopefully we can continue our work from there. So, well, question I guess will be later.
Thank you, Lior. So next I'd like to call Val Penchev up, please. Val's going to talk about the new Cadre project. Val works at IUNI at Indiana University, and he's been a long-standing member of the Hub. So thanks very much. Come on up.
Hello, my name is Valentin Penchev, and I've been here for quite some time. I was in the original charrette of the Hub. I was at every all-hands meeting since then, and I'm part of the Network Science Spoke of Indiana University. And when I usually come here is to present some of the really great projects that Indiana University Network Science Institute has been involved in. Let me see how this works. Okay, a little bit about us. The IO Network Science Institute was formed in 2014, just a year before the initiation of the Hub. We are intentionally started as an institute which is not part of any school. We don't have a dean, we don't issue degrees. What we do is promote the use and research of network science and work with more than 160 affiliates at IU and many around the country. So going back to all the cool projects I was showing and presenting here before, like the graphical interface of Indiana legislative data, like the Observatory on Social Media, which is very relevant today, especially on the election day. And I would urge you to go check our misinformation visualization tools like Hoaxy and a new challenge of what bots are talking on election day recently in the media. And I go with this introduction just because the project I'm about to speak, the Shared Big Data Gateway for Research Libraries, and its product, the Collaborative Archive of Data Research Environment, or called CADRE, is something that we haven't built yet. It's something that we're just starting our journey on. It is a 2-year project sponsored by the Institute of Museum and Library Sciences, in a cost-sharing proposal between them, us, and a slew of other companies you would see on the back slide, including Microsoft Research, Claravet Analytics, the Midwest Big Data Hub, all 4 hubs actually, the Big Ten Academic Alliance, and many, many more. I'll go to that later. I would like to start with a little video just to lighten up the mood. Keep in mind this is a marketing video meant to secure the support of the Big Ten Academic Alliance and the research libraries around the country. It did its job. We did get the funding, but don't expect to see some real technical details here. Can we cue in the video?
The field of science seeks to quantify aspects of scientific discovery, creativity, and practice through research and the development of tools and policies aimed at accelerating scientific progress. The emergence of this field has been driven by technological developments that have enabled the collection, curation, and analysis of large bibliographic datasets, such as the Web of Science, a proprietary dataset with over 68 million records, and the Microsoft Academic Graph, an even larger publicly available dataset. While these large bibliometric datasets are of great value to researchers, getting them into a condition in which they can be most useful poses some unique data custodial, stewardship, and management challenges. The Big Ten Academic Alliance recently used its collective bargaining power to purchase the Web of Science data at a rate far more favorable to BTAA member libraries than if they had purchased it as single institutions. However, the Web of Science product as purchased is not ready to use out of the box. The data are mailed on a hard drive from the vendor, Clarivate Analytics. The core dataset is roughly 130 gigabytes compressed, while annual updates are approximately 10 to 15 gigabytes each. Uncompressed, the raw XML files amount to more than 600 gigabytes and come with a 170-page data dictionary. The IT team at the Indiana University Network Science Institute, or IUNI, has developed software to pass the raw data into a relational database. A relational database has an important advantage over the raw data. It allows for much faster queries and computation for analysis of citation networks, co-author networks, and other networks employed by heavy users of bibliometric data. The parsing is a labor-intensive process that has to be repeated annually, since each add-on comes with updated and expanded fields compared to previous editions. Using IU's vast supercomputer resources, an annual update of the Web of Science database can be completed in a matter of weeks. The Web of Science data in raw and relational forms is currently hosted in a secure enclave at IU on a dedicated node of the IU CAST cluster. The database itself occupies about a terabyte of space and takes advantage of all the power available to the node. Being part of CAST allows researchers to use the modular software available on the cluster and the data manager to submit parallel requests to multiple nodes when more processing power is required. The Web of Science Enclave is a secure environment in which users with sophisticated programming skills can explore the data in their native form, interact directly with the database, or use a graphical web interface that guides the user through the querying process. Accessible only through a secure remote desktop connection, the Enclave provides researchers with a plethora of available tools and resources. No data may leave the Enclave without the explicit authorization of the data manager. The Microsoft Academic Graph data is stored in the cloud on a Microsoft Azure data lake. iUni IT has partnered with Microsoft Research to ensure new versions of the entire dataset are deposited on a bi-weekly basis as the vendor refines and expands content. At about half a terabyte for each distribution, a significant amount of storage is required to host every published version of the data. iUni IT has been researching different ways to make both datasets available to a larger audience. Currently, the team is exploring cloud-native technologies like dynamic schema data lakes with USQL and a variety of graph database solutions. Initial experimentation has resulted in a significant improvement in query times compared to a traditional database of a similar size. Combining efforts of multiple institutions to create a shared big data gateway for research libraries will benefit the entire community and give all its members access to resources not available at an individual or even an institutional scale. Through this partnership, iUni and the BTAA libraries will create a pioneering venture in academia, a self-sustaining data mining observatory responsive to researchers that simultaneously supports the practical business needs of library contractual agreements.
Cute, huh? Again, this video was meant to be shown and was shown in the Big Ten Academic Alliance meeting. That's why the emphasis on the BTAA. The idea behind our shared gateway research, shared big data research gateway, is the usability of proprietary big data sets like the Web of Science data, but also the inclusion of the freely available data sets like Microsoft Academic Graph. Those are bibliometric data sets to start with. We hope to be able to increase this to a large variety of data sets in the future. What is ahead of us? Identifying our primary constituencies, our constituencies in general. The primary ones are the research libraries and the science of science researchers who really need to use those data sets. The secondaries are the public libraries and smaller community and non-R01 colleges. Again, we were able to convince the BTAA that it's too much for a big institution to do everything required to host Web of Science and Microsoft Academic Graph on their own. It is cost prohibitive to anyone smaller than that. We estimate about $500,000 worth of infrastructure and licensing fees just to be able to provide the Web of Science hosting for an entire institution. And finally, our tertiary constituencies, administrative bibliometric research institutions, and the general public as well. As every other tool that iUni has produced in the future, they are completely open to the general public. And what those constituents needs? We're trying to understand the user's needs and expectations from the get-go. Usually most of the critiques I hear about any IT project is we like to play with big shiny toys. We build them and then we send them to the researchers for use. We're trying at iUni and the Cadre project to overcome this by starting to solicit user stories and relying on a product ownership council, which is comprised from researchers from all the institutions participating in the project. Shaoran Yan, my colleague over there, who will be presenting a poster, is also charged with creating and delivering those user stories. So if any one of you is interested in bibliometric data studies or know people who are doing science of science research or have links to your own research libraries, please make sure to stop by our poster and talk to him. There are also people who are interested in information computer science, part of the bibliometric studies, and I'm listing them here because they're so different from each other. The first group cares about APIs, Juniper notebooks, access to raw data. Those are the people who usually have their own labs with postdocs, graduate students, and researchers. There is a second streak of the science of science community who know how to access a database. A SQL database, usually. Okay, so I have to hurry up a little bit. What I'm trying to say is there is a diverse research community of people who really know how to explore information technology, people who can access a regular database interface, and people who are great researchers in their field but are not that computer savvy. For them, we're trying to build a web interface. I have a lot of data on those slides. I'm not going to go through it, time permitting, but they probably will be archived for people who want to see. We're going a three-pronged approach with keeping the actual data on its native form, which will allow the use of the new cloud-native technologies like USQL, like Athena, like Glue, and so on. It will allow also use of Spark, Databricks, your own Hadoop clusters, or our cloud resources. We're trying to start the research on the best database access, being relational databases, graph databases, and so on, and finally build a web interface which will hopefully be able to guide researchers through their query building and suggest the best technology. Last but not least, the research commons, which will hopefully facilitate reproducibility, repeatability, provenance, transparency, and so on. This is the part where people will be able to share and save their derived data sets and be able to assign DOIs and actually publish papers with them, hopefully later on. It will all be part of a federated logging system, which if you're part of participating institutions who have access to proprietary data sets, we'll give you those. For everyone else, we'll be able to use the free tier available. Everyone talks about sustainability of the project. Again, this is funded by IMLS for 2 years, and I'm happy to report that 9 of the Big 10 institutions have signed commitments, pledges to support the project for at least 3 years after the initial 2, which we have funding for. This is how it looks like in our minds, what we're trying to build. We hopefully will get there. And this is where you can find us with all of our partners. I think this is it. And that's the entire team.
Thanks, Val. We will have plenty of time for questions. I think these 4 projects or initiatives will engender some great questions. So we'll have plenty of time before lunch for additional questions. Okay, Jim Barkley, I'd like to call Jim up to talk about the new Advanced Materials Manufacturing Working Group. Let me just mention that all 3 of these gentlemen are on the MBDH Steering Committee, and we're grateful for their volunteer efforts around steering committee activities. So thanks very much. Come on up.
Thank you, Melissa. Hi, everyone. I'm Jim Barkley, and we're starting a new initiative, but in some ways it's actually not that new. So before I delve in too much, just wanted to offer a little bit of a historical context. So I've been working with the MBDH since its inception, really, and pioneered a spoke proposal, actually, to NSF around advanced manufacturing. And ultimately it was not funded, but we sort of said, we're going to do it anyway. And many folks were on that proposal. Our host, Case Western here, was actually co-PI. I think they had 1 or 2 co-PIs on that proposal. So we've been, rolling forward kind of grassroots over the last couple of years. We had some students do a poster session at this all-hands meeting a couple years ago. We've championed kind of manufacturing and material science in various venues. Last year, about this time, I was out at the Internet of World conference in San Diego, and that was a really great opportunity to kind of promote the hubs, and all the hubs, but ours as well, and just the different things that we're doing. We got a little cadre of interested folks there, and then this year, Melissa and I tag-teamed a robotics session. I also did a blockchain session at an Internet of Manufacturing conference in Chicago, which is where I'm based. And so we've been slowly sort of building a critical mass, and we said, okay, it's time to formalize that. So that's what we're here doing. And how do I get this thing to go forward? Is there? Thank you. So we're formalizing this into an actual working group on advanced manufacturing and materials. We had our sort of initial kickoff meeting yesterday. These are some of the folks that were involved in that early session. So myself, I run a company, a software firm that I founded in Chicago last year, mostly just so I could, wear sandals whenever I want. Yeah, that really spun out of my involvement with the National Manufacturing Institutes, and specifically a Digital Manufacturing Institute there in the city of Chicago. But also from that, my co-chair is Shiva. He can't be here right now. He's on his way, but I understand he's running a little bit late. From University of Akron, and he's got a lot of experience in this sector, worked at Rockwell for a while, and is associate professor of electrical and computer engineering now. In addition, we've got some other folks, actually that's on the next slide, so I'll talk about them in a second. But our goal here, fundamentally, we're trying to drive a national agenda around manufacturing. We want to get people excited. And it's, there's pockets of research and interest here and there. And I think there have been, things are starting to coalesce from the vacuum a little bit. And we really want to bring that group together and promote a national direction about all of these various technologies. So that's really the takeaway here. As I said, this is the cast of characters. Brent Bowden is also involved, joined us yesterday. He's actually the Chief Technology Officer for the Digital Manufacturing Institute in Chicago, but his other job, he likes to say he's mini-hatted. His other job is at the Air Force Research Labs. We've also got Mike Branicki from the University of Kansas. He, I believe, actually was pretty instrumental in getting the Cyber Physical Systems Program Directorate started at National Science Foundation. And then lastly, Dr. Benil Starley from NC State. So we've got about 5 open seats right now. If you know of people that may have an interest in this, this intersection of big data and the manufacturing and materials science world, please let me know. We're just a couple of other folks we're in talks with about putting on the roster, but that's sort of the direction we're headed. We'll be coordinating, as Melissa mentioned. I'm on the steering committee, the MBDH steering committee, and I have been for the last couple of years. So I'll continue to coordinate with them. I understand that structure may be changing and morphing a little bit based on the new solicitation, but we'll continue to interact directly with them. And then Shiva's kind of taken the lead on connecting with the spokes and other big initiatives happening. In terms of the things that we're seeking to do, again, we want this to be kind of a grassroots effort, and so we're not trying to go too big here, but we do think it's important to get a position out, and so we're planning to put together a position paper on our areas of focus, as well as get the right folks in the room together at the right times over the next year, and potentially position a couple of focused and meaningful webinars. We were joking around yesterday, there's no shortage of machine learning webinars in the world, but tight focused areas around manufacturing and material specific technologies actually are pretty rare, and so we'd like to put some energy behind there. And we've got about a year to see if we can really generate a national agenda and excitement around this. So that being said, what are our key areas of interest? Well, we're still sort of forming that, so I don't want to put a laundry list up here, but I wanted to give you guys some ideas about what we're thinking. And to put that in context, first of all, this is a little bit of an Easter egg. Is anybody here familiar with this framework, NanoBioInfoCogno? No? MBIC? Yeah, okay. Yeah, this was something actually, some papers on convergence that stemmed from National Science Foundation in 2003 and then again in 2005. And now, you know, in 2016, I think they formed a sort of a convergence program thrust. But this research goes back to the early 2000s, and it was really a commission to a couple of papers around where's the technology headed by 2020. And what's cool is that if you go read that paper, all of these things on here are there. You know, they predicted in 2003 that we would have ingestibles and implantables and, you know, all of these interesting things. And then eventually, at some point, somebody realized that robotics was kind of missing from here, so they threw that in. The key areas that we care about in sort of manufacturing materials are really, we're focused on robotics, info sciences, and now with AI, some of the cognitive sciences. You could argue nano's in there. We're kind of staying away from that. That's a pretty niche materials group, so it remains to be seen how much we actually focus there. But what's interesting about that is those papers were focused on the convergence of those four disciplines. And I'm sure many of you are familiar with the wisdom hierarchy here. It's just kind of a simplistic model of how we turn information into actual useful wisdom that we can use. And so I'm not going to go through it. The core are kind of the pieces on the pyramid. But I did add a few things here. One thing that I think is interesting is that the whole thing is predicated on a foundation of trust, which is often lacking in the model. And so we have to fundamentally evaluate technologies like blockchain, you know, and those kinds of things. So there's a big cybersecurity thrust in here. Also, at the top of that pyramid, it really doesn't account for how we take that wisdom and do new things, right? Sometimes we call that innovation. But what's also interesting is that it takes time to go between the layers of this pyramid. And it doesn't just go up the pyramid, there's actually feedback loops. Every time that you transform information into knowledge, you actually learn something about how maybe you should instrument your system better. And so there's this back propagation, and in both directions of that flow, there are time delays. And this convergence of all these technologies is really reducing those time delays. And that is fairly profound. This is an overlay of some of the things we think that are really at the heart of that, just technology-wise. Ubiquitous sensing. I mean, you can buy a really amazing LiDAR radar for you know, $140 these days. Big data, of course, and analytics really help us capture information and organize it in a way that we can actually query it and try and transform it into useful working knowledge. And then decision automation, and AI kind of cross-cuts all of those things. So when I talk about convergence, you know, part of what's important I think is going to be important to this group is the convergence of the and the reduction in the time delays to go between these layers of pyramid. What's important about that is that it's going to transform the economy and the producer experience and the consumer experience. And so that's why this is connected to manufacturing and materials. One interesting trend that I'm starting to see is a move away from the kind of the big data verbiage to smart data. You know, the computing models, the data models, the consumer models, they're all moving towards micro-targeted, very high precision, transactional kinds of relationships and business models. And so that's what we mean by smart data. It's about bringing the right data together at the right time. You know, I mean, you know, who wants a data lake? You know, I don't want to offend anybody. There's uses for them, but you know, like if I'm trying to drown somebody. But you know, so it's really a movement towards this fluid computing, and so a couple of areas in particular of interest are obviously artificial intelligence is a very big topic. This is a nice framework from the World Economic Forum that I really love around kind of the different stratification of AI. And so the box in purple there is probably what's sort of scoped area for this group, this working group. You know, we don't want to look 30 years out too much, and we don't want to do things that you know, have already been solved. Augmentation and you know, virtual reality, augmented reality is a topic. Remains to be seen how much we'll cover that. But, you know, it does come up in conversation. I just want to give you guys a glimmer of how that manifests itself in manufacturing. So this, that picture on the left is somebody actually using an augmented visual overlay to figure out how to do some kind of assembly process in a plant. On the right, this is from an SAP video they're doing in conjunction with a company in Silicon Valley called Scope AR that is really a maintenance function, right, with overlays about how to interact with the world. Obviously, robotics. I'm running short on time, so I'm going to blow right through this one. But there's obviously a lot of advancements in robotics that we care about, especially with respect to automation, but also with respect to replacing the workforce or augmenting the workforce, how we interact with them. You know, this is a big topic. Smart cities is another big one. This is just kind of an underground mapping research project that was done with the city of Chicago. As an example, you know, these are some of the top smart city initiatives. But I really like this, this verbiage around connected communities. And then, of course, changing the way we work. The last thing I'll leave you with is there's a great study. So this is a taxonomy of how the manufacturing workforce is going to change. These are 160-ish jobs of the future for that sector. And one of the interesting sort of facts and figures behind this very detailed 208-page report is, I think, comes from a study called Shift Happens. And they have this staggering statistic, something like 40% of students in primary education right now will be working at a job when they graduate that doesn't actually exist yet. And so obviously this is a big area of exploration for not just our working group, but for the MBDH and NSF more broadly. So we'll be connecting, and I suspect a lot with you folks on this kind of topics. So I'll leave it with that and take my seat on the panel.
So I will briefly chat about this and then invite the speaker up to talk specifically about the Open Storage Network. So last year, a proposal went in, led by Johns Hopkins University. Alex Saleh and Johns Hopkins was the lead proposal with the 4 big data hubs attached to that to build out a demonstration project for an open storage network, a petabyte scale network. It's in its pilot phase now. The goal is for that to become, or at least hopefully to become, a national 100 petabyte scale substrate to existing advanced research computing and networking investments that NSF and other agencies have made over the last several years. So we have a node of the Open Storage Network at NCSA, that is the Midwest Big Data Hub node. Santiago Nunez Corrales is going to come up and tell you more about the project. It is still in demonstration phase. We won't actually be taking data for some time, and he'll give you the details. Thank you.
So hello and good morning. As Melissa said, I'm Santiago Nunez Corrales, and my role is as the outreach coordinator for the OSN. So the basic premise of this project is as follows. If we want better science, we do need shared data to access shared data in more intellectually efficient and technically efficient ways. And that's what the goal is from the perspective of the PIs in this whole endeavor. We are also seeing a multitude of multi-petabyte investments across a broad range of universities that says that they're generating much more data that they can handle at present. And also we're seeing that there's a very interesting type of data set that's emerging in these collaborations. It ranges between a few hundred megabytes to up to tens of terabytes. They don't go into the petabyte scale. And some of those data sets serve for benchmarking different applications, some others serve for collaboration between interdisciplinary domains, and that's where the OSN wants to focus on. We do not focus on archival storage, since that's more related to the responsibilities of institutions generating the data. So how do cyber infrastructure resources at present stack up? In terms of computing or high performance computing to be more precise. We have Exceed. It has generated a standardized form of accessing the resources, and it has been funded by NSF by a long time. What about networking? The CC Star project, especially CC Star NIE, has provided roughly 200 universities with high-speed data links that are also standardized and continue to have funding. But the story about storage is a bit different. We still see pockets of data being created. They are not connected. They don't share a common standard. They actually don't have standard requirements. There are more de facto ways of working through the disciplines. And up to this last year, there was no cyber infrastructure funding for it. The whole idea of the project is, instead of course, a centralized entity, we want a distributed network capable of scaling to national level that harnesses those 200 plus high-speed links at various institutions and creates a resilient, robust network for sharing data. So Alex Saleh put it very, very good in a talk recently. The problem here, there are technical problems to be solved, but the main problem is that social engineering, so that the platform that is being deployed becomes attractive for people at universities to commit to and to manage. We all know that having access to a new box or getting a new box comes with a new set of responsibilities, and they should be manageable to the extent that they become very attractive to have them and to produce new types of science. So it'll have unified administration, standardized, and it'll be a standardized and scalable system. And we want to have also fast, reliable data transfer with high performance. So in terms of goals, we do have technical and science goals, especially leveraging existing cyber infrastructure. We do not want to reinvent the wheel and make it square at the same time. But in terms of science too, we also want to trigger things like prompt definition of data standards, to find community-built tools that already exist and are great for doing the data transfer, data sharing job, to cultivate data discovery. People across domains should be able to find the data, and ultimately to foster multidisciplinary interactions. And that's what the NSF Big Ideas, 10 Big Ideas wants to do. When we look at the existing nodes, they conspicuously correspond to the big data hubs that we have today. And the first node was deployed at JHU thanks to the Schmidt Features Foundation. And the next phase of the project will be deploying each one of the remaining 5 infrastructures. And we happen to have one at NCSA, which graciously hosts and supports the project. So in terms of hardware and software architectures, it's being in development at present, but the idea is to have a box, an appliance, a storage appliance that can be deployed at a research university that connects to the high-speed networks, roughly beyond 1.5 petabytes. It's 1.5 plus petabytes. We're working on the plus at this point. And it'll be connected and internally modeled with respect to object storage. In terms of the service, we expect, if we look at the diagram, it says data contributors. They can come in from instruments, sensor networks, and they will access a single API that leverages both the S3 interface for data transfer and as well as the Globus authentication. We plan to, we're evaluating the presence of more standards at present as well. And for people that consume the data, they could do so by portals that access the same API, or by directly accessing the API, for example, for batch processing modes. In terms of the science use cases, they are varied, and we have chosen 11 of them for the initial testbed. And you can tell that there's a whole bunch of diversity here. So we have neuroscience, earth sciences, climatology, astronomy, bioinformatics, and the total data volumes and the average size of the data units also varies. We are trying to capture as much information from the variety and the types of data that we can find in those data sharing units. In terms of the project timeline, this is a 2-year project funded by NSF again, and we are here today at the point of deploying and designing the prototypes of the storage appliances. Next, we'll perform verification, and in the end, this work will serve to inform NSF's coming solicitation for the national or scaling up to 100 or 200 sites. So one example is the Terra Basic Fusion project. We know that NASA has the Earth Observatory System, a set of instruments and data products, but 5 of them constitute the Terra data sets, basically looking at things like land composition, aerosol effects, and carbon monoxide. So here, the main scientific drivers seem to be climate change, geophysics, for example, volcanology, computing what happens after a volcanic eruption, how volcanic ash affects crops, for example, could be one example application. And the main data product that they have is a basic fusion file. The idea is to integrate, but whenever you want to look, here's the problem. Whenever you want to look at a specific region, the tiles are not standardly co-located in a single downloadable file with a certain standard. You need to do the stitching, you need to do the corrections, the orthographic reprojections, and so on and so forth. When these products are available, we'll have a total size of 1 petabyte for the whole data set. The average file size that's shareable, and it's a meaningful unit, ranges of around tens of gigabytes. It's being designed with HDF5 and HDF4. The data organization unit is a remote sensing mission or orbit at present. So that corresponds also with how the paths of the satellites taking the images. It's currently stored in Blue Waters, and sharing, this is a joint project between NASA and NCSA, and it's shared through the NASA Earth Data Portal, and there's work to do that on the National Data Service as well. So why OSN and the big data hubs? Where do they intersect? Number one, this proposal originated along with the data hubs, and it is a co-designed process. The hubs are the primary source of information and experience in the data space for many of the activities that we want to integrate. And it is actually breaking ground together. There's another activity which is a scale-up engagement, which is to concentrate and channel the existing user feedback about efficiency and effectiveness. The hubs know what the users need and what will be probably needed in the future, and we need to accommodate for that. There's also the need to identify and make visible new requirements continuously. Given that this project is breaking these new grounds, we need a lot of feedback of what other data sets are useful. What happens when we have, for example, I don't want to go technical, but if we have collections of very small files, that's a different performance, a boundary condition than if we have very large files that need to be transferred very quickly. Also, we need to help develop and refine the data governance schemes that are broad and deep at the same time. We want to try to cover as much as we can. And finally, community building. The big data hubs are uniquely qualified to suggest interesting projects. And this is the case certainly for the Midwest Big Data Hub. And the OSN will amplify, and this is our task on the end of the OSN, to amplify and showcase data sets resulting from BDH efforts at national scale. So with this, I'll leave you with these items here. Thank you very much for listening.
Okay, so we have plenty of time for questions now, and I'm hoping that these 4 very different projects, but very interesting and exciting, that you've got some questions at hand. So I will wait. Any questions? Please, Brian. There's a mic coming to you. Thank you.
So Brian Yandel at University of Wisconsin-Madison. So I think of equity and diversity and inclusion as being central to making progress in data science and developing the next generation. So I wonder if the first speaker could speak to how we move from, you talked mostly about undergraduate universities. How do we move that idea to R1 universities?
Oh, it's on. Right. Yeah. Thank you for the question. Right. So our initiative the majority of the people participating are from PUIs, maybe, but not everyone. I mean, there's it's a fairly diverse group of people that covers all types of academic institutions. So, at the level of the research institute, when you have larger courses and different population of students, but we also, part of our activities of what we plan to do is to develop all sort of like research modules at the entry level of data science. So they don't require, let's say, programming experience, or you can start right with that. So there's no, programming is not necessarily a barrier that filters a lot of the potential students that might not see themselves as programmers. Also, we develop those models in a culturally responsive manner. So we focus on data science by analyzing things like music, for instance, like sports, like things that students can express themselves, can express their culture, can express their identity through the things that they do in the classroom. And it's all, mostly it's designed for the freshman level course, for the introductory level courses. Other activities that we're working on planning to expand is the integrated data science, to include data science modules into other disciplines that are not necessarily data science, even things like the humanities. When people go to the humanities, they don't necessarily see themselves as data scientists, but they are exposed to data literacy and data science through those courses, giving them the choice to see, hey, maybe there's something, maybe they want to pursue that further. They just, before they make the decision of what major they choose, they weren't aware of, and we know that we have a lot of underrepresented populations in STEM, but in fields like the humanities, like social science, the situation is not as is not such. So we can take advantage of that, reach out to those students, and kind of expose them to more directions like that.
So I'd like to just add on to that, if it's okay. In addition to the data science across the curriculum approaches, and so Lior mentioned several models for that, there are also opportunities to engage students in direct action, if you will, so data science for social good types of approaches, and whether that's done through a consortial model and working with other institutions that have centers for data science for social good, or developing student-led organizations on your campus that are formal with a faculty advisor who can work to connect to outside organizations or even internal units on your campus to help drive entire projects to help solve some problem, enable decision-making, or address some grand challenge that's of relevance to the community. So there's also that opportunity to help bring in new students who are interested in engaging around a problem, and that really inspires and brings new students to the table as well.
If I may chime in as well, behind every great asymmetry, you can always find a hierarchy of incentives that needs to be changed and rebalanced for redistributing the benefits. And I think one of the things that the Midwest Big Data Hub and all the hubs do as well is provide evidence to people who design these incentives. Because there's one thing to do activities that show that work, and the other one is to sustain the momentum and make it generalizable to the broader community. And that requires definitely generating incentives from the faculty level to the research level to the outreach level as well. So but there needs to be a rebalancing of hierarchies of incentives.
Thanks. Additional questions? Okay, well, I have a couple, of course. So a lot of these initiatives or projects are just launching now. So, of course, the one thing we'll want to do before lunch is make sure that we reiterate all the contact information. But while these projects sound very different, the underlying effort around this is increasing access and use of data to help solve grand challenges, drive decision-making, build new collaborations or opportunities for innovation. And so in the innovation space, if you all can be thinking about sort of a potential outcome, and I'm not going to put anybody on the spot exactly, but I'd like to hear you talk a little bit about making that leap from we're building, frankly, some fundamental infrastructure here and new collaborations around new approaches to what we're doing to help drive some innovation whether it's in technology, data science education, or data access and use for new science. So potentially, someone might have some thoughts.
Is your question?
Dan, thank you.
Dan Lenzel, University of Nebraska. And of course, I have a question too, right? So, so this question is for Jim. I'm just curious about the working groups, what their thinking was in terms of ubiquitous sensing in the manufacturing area. Like, what's the I'm a civil engineer, so I'm not very smart. So, so I'm just wondering what the current state of the art is, if you're interested in just gathering that information, or developing new sensors, or starting to at least get a critical mass heading in a certain direction.
I think they're on.
Oh, yeah, great. Thanks for that question. Well, we're still sort of debating where exactly we want to focus, but you know, I would say a big bridge between the material science side and the manufacturing side is understanding at a finer grain level, all the way down to molecular, how interacting with various materials in different manufacturing processes actually changes, you know, various properties, all the way to the prediction of the part performance as an outcome. And you know, there's different ways people talk about that. Integrated computational materials engineering was a big topic for a while, still is a hotbed in a couple of places. Process modeling is another way people talk about that. But really, being able to shift left and move further away from destructive testing and quality control processes, I think is a big focus area. And so a lot of that is about how you can sense the process in real time, or assess at that level of detail how things are operating on it. There is the product side as well, you know, about how you build sensors. I think our sense right now is probably we're going to veer away from that a little bit. You know, how you build a better infrared sounder is not something we really see as in our wheelhouse.
3D printing, I assume, is a big component with this. Whenever I get people that are worried about, again, the material properties are a lot of relates to what 3D printers are producing and how they're utilized.
Yeah, and it really is a big data problem. So, you know, one sort of newer 3D printer model that is getting a lot of buzz is called Carbon. I don't know if you've heard of these guys. They have hundreds, it's, you know, it's one of those Terminator rises out of the, the goop kinds of processes right there. The part literally rises out, and then they're focusing light on it to cure it at multi-layer as it happens. And there's hundreds of parameters that can be tuned. One run on a standard part produces about 4 terabytes of data. And so understanding all those properties, yeah, 3D printing is definitely a big part of that. I mean, the other side of it is, you know, and I think some of the low-hanging fruit for a lot of manufacturing shops is just how can I better outfit legacy equipment and my existing shop floor to better manage, you know, efficiency, part prediction, things like that.
Lei Wang from Northwestern University. I'm part of the Computational Neuroscience Hub. So the question is for the Open Storage Network. So I think it's a really exciting project. It's time also to think about how to build infrastructure for the vast amount of data. My question is, you know, about 15 years ago, I think about 15 years ago, right, NIH had an initiative called the Bioinformatics Research Network, or BERN for short. And as part of that, they also try to develop storage infrastructure and pushing out hardware and so forth. Of course, things have changed now in 15 years. There's a lot of development in terms of technology and network and so forth. But back then, that particular effort for storage wasn't successful in terms of wide adaptation for its use. And they were trying to push out racks and network and so forth. So I wonder if there's been lessons learned in terms of user community buy-in, or you think there are challenges, particular challenges in terms of wide adaptation for this technology. And I want to add that personally I want to work with Open Storage Network for one of my projects. So I'd like to hear your thoughts on that.
Great, thanks. You want to go first? Because I have some direct answers for Lei as well. So, okay, go ahead.
So first, we'd love to hear from you, and we'll keep in touch, definitely. So in terms of lessons, to the best of my understanding, part of the problem in the past has been the scale, and by scale, I mean diversity of fields. So this justifies both the need, in order to have something that justifies such need, you need to have a large volume of data that will be transferred and used frequently. Something important is that this data set, bioinformatics is one great community, but that is just one particular use case. We need more use cases from more areas that generate enough traffic. We have very fast data networks, so that also the cost of storage is sufficiently amortized in time.
So thank you. I would like to just let you know that we had an architecture meeting recently, and I actually used your case with your data as one type case that we should think about, and I called it cache and release, and I think that's a really nice way to think about that, and we could talk more about that. But we'll be supporting data and communities that need access and flow through in different kinds of ways, and so we're happy to engage. The current use cases we have, they're identified in the proposal itself. We'll start with those folks in the spring. And then next summer, August, we have planned a wider community engagement meeting around the Open Storage Network. We will be looking for people to come to that and give us feedback and input on that. And we'll be looking for some new folks as well to talk about efficiencies and opportunities. The OSN will also have a Birds of a Feather session at Supercomputing that's happening next week, so you're welcome to join that. And so we've already started engaging higher level community feedback. So your point about Bern is well taken. I actually was, I was around the neuroscience community when Bern was being rolled out, and so that's a really nice project for us to be thinking about, looking at outcomes of that. But so I think one of the things I just want to note is different as you did. 15 years later, we have the investments of the national networking, we have NSF's investments in networking. We have the Exceed resources that has, vast training services and governance processes built in that we can leverage. We're working with Globus, which Globus has an eager award to develop some of the baseline software services we'll need for the OSN. So we've got some pieces in place now that potentially were part of the development of Bern, and we're not trying to push all the hardware out from a single place, although we are trying to standardize on the hardware across the nodes to be able to test similar systems, right? So I really appreciate you bringing up that example, and I think one of the ways that we're working really hard to be different early on is this kind of engagement right out of the gate. We won't even have boxes built and stood up until January or February. And so being able to get community feedback very early in the process, we are hoping is going to really help us drive some success in the demonstration project. So thank you for that. Any final questions? We are approaching lunch. Okay, so let's thank our panelists again. Really great projects, thank you. It's time to grab lunch. About 12:30 or so, we'll have some remarks from Sarah Nusser, and then introduce our keynote speaker, Dr. Rocky. Thank you.
I'm very sorry to break up, ooh, wow, that's loud, that was quick. I'm sorry to break up all the conversation. We have a wonderful keynote for lunch today, and I thought I would just give you a few remarks about the digital agriculture community as part of the Midwest Big Data Hub. This is a very important community for the Midwest Big Data Hub, and it was really one of the earliest groups to form. Involves collaborations throughout the entire region. And in fact, Sally Rockey, our keynote today, was at our first all-hands meeting for the hub and in digital agriculture in May of 2016. So we're glad to see her back. That meeting brought representatives from several different sectors together to discuss the kinds of issues we were having in digital agriculture and how to move forward. And since that time, we have engaged in a number of activities, some of which you've already heard about today. For example, the UAS spoke, but also we've been running summer seminar series around phenomics and genomics. Last year at the all-hands meeting, we hosted a conversation with USDA on digital agriculture and agricultural data. And there was just an all-hands meeting for digital agriculture at the University of Nebraska-Lincoln. So it's only fitting that Sally has returned to the all-hands meeting. And I'm sure you all know that Sally Rockey became the inaugural executive director of the Foundation for Food and Agriculture in 2015. And prior to this role, Sally had really spent her time overseeing federal research in a number of different ways, both in USDA for 19 years, where she was not only overseeing research, but she was a chief information officer for a while, so that connects to us, and part of Extension, which is also very important to us in the Midwest. At NIH, she ran their extramural program, and then as we all know, she has been leading FAR, the FAR, is that how we say that? FAR. She's been leading FAR since 2015. She is also a Midwesterner, both by birth and through her education. So we're very pleased to introduce Sally Rockey. Please join me in welcoming her.
Thank you for that wonderful introduction. Yes, I grew up from my middle school years outside of Cleveland here in Bainbridge, Ohio, and I am a Buckeye, OH. All right. Actually was at the game this weekend, which was quite nerve-wracking. So Buckeyes aren't quite where we need them to be. But thank you so much for having me. I'm going to talk a little bit more about digital agriculture and also tell you about our foundation and where we sit in this place of funding research and then what the future may hold for all of us. Because in the agricultural space, big data, data analytics, artificial intelligence, deep learning are all going to be so critical for our future. And we're really looking to all of you for that innovation in this space where we can take ourselves and agriculture to new heights. Our mission, my foundation's mission, we were created in 2014 out of the Farm Bill. We received $200 million from your tax dollars, so thank you very much for that. We are a foundation, we're a 501c3 charitable foundation, but we are associated with the USDA, so we also seek to support the mission of the USDA. And not only do we aspire to seek partnership with the private sector, aspire to do that, but we're required to do that. So for our $200 million, we must match it with non-federal funds. So this is really important. And what we try to do is work in that innovation space with public-private partnerships. Now, why was our foundation created? If you look at the amount of funding that there is for agriculture research in the federal government, ag research only comprises 2% of all of the research that the federal government pays for. If you take out defense, it's only 4% of the research. So there was a reason to grow the pie in ag research. But the other thing that we have to see, that we've been seeing is the real switch. As federal funds have been flat over the years, the amount of industry support in agriculture sciences has grown tremendously, so much so that industry support of agriculture research eclipses federal support threefold. So our foundation, to bring those two, to leverage that funding of the federal public sector funding with the private sector is really important, because that's another way to leverage the funds, but also where a lot of the action is taking place is at the private sector. We also work very closely with philanthropic organizations, and I'm pleased to say that we've had quite a bit of interest from philanthropic organizations that typically haven't worked in the ag sciences, particularly when we're working on that relationship between agriculture and health. And so we've been able to foster relationships with philanthropic organizations and other non-traditional partners that can come in and support agriculture. I oftentimes dream about what it would mean to have the kind of funding that NIH has. I was at NIH for 11 years as the deputy for extramural research, and I saw what that power of funding can do. Not only does it have to fund a lot in quantity of really high priority science, but it allows the agency to take risks and really move into the innovation space when they see that. I always imagine that if agriculture had that kind of funding, where we could go. I'd like the Dr. Seuss book, Where We Could Go with That Funding. And if you look at really how agriculture sciences impact our lives, it's absolutely incredible. I mean, we're all enjoying our lunch today. We eat at least 3 times a day, some of us more than 3 times a day. And but really on the quality of our life and on our ability to live a high quality life is so dependent on the food that we eat. When I was at NIH, I oftentimes showed a chart which showed the increase in life expectancy over time. And if you look in the United States, our life expectancy was 46 in 1900. And by 2014, our life expectancy for women was over 80 and for men nearing 80. And it hasn't been for the last 2 years that life expectancy in this country has actually gone down. But even at that time, I gave a lot of props, not only to biomedical research, which has helped us fight disease and chronic illnesses, but to agriculture and agricultural sciences, because our ability to eat safe, nutritious food, particularly for mothers and for their infants, and as well as to fight foodborne pathogens, has really led to an increase in our life expectancy as well. And if you look at one of the reasons that our life expectancy has decreased is also food related. It's because of the obesity epidemic in the world and the chronic diseases associated with obesity. So we have 3 things happening now that's reduced our life expectancy, not only obesity, but suicide and the opioid epidemic. And those 3 things combined have actually seen us to reduce our life expectancy. So we're expecting science to take us back to where we were, both in the biomedical and the agricultural sciences. So we have this wonderful vision for our organization. We envision a world in which ever innovating and collaborative science provides every person access to affordable, nutritious food grown on thriving farms. And one of the things that's very important in this statement is thriving farms. And I'm going to talk more about that and where big data and data analytics can really help farmers. So I mentioned all of these things, but one area where there's research gaps that we try to fill is areas where data are going to fill those research gaps. I would also point out that we work with the private sector, so we are publicly funded. And one of the things that we require is that the data that we generate through our programs, even when our funds are mixed with the private sector, are available publicly. Now, we can make certain requirements about those data or about the relationships. For example, when we begin a consortia where we might have a funding consortium where we might have a number of private sector companies mixed with our funding, we will allow things like data embargo. So we will say you must publish, but we can hold it for up to 24 months. That incentivizes the companies to come in and work with us, and then we release those data as quickly as we can after the embargo period. But because we work in that pre-competitive space, that space where everyone's going to benefit from the results of the science, most of the time our data can be released almost as quickly as it's generated from our projects because there's no commercial value at that point for these companies. And with the agricultural companies of late, because of all the consolidation of the companies, there's a lot that we realize that we can do together more efficiently and effectively than we could do otherwise. And so companies are more willing to join these consortia, and our seed companies, the innovation the IT companies, the tech companies, and others, where they may not have before. So we're in a good point in our lives as far as agriculture and forming these consortia. Now, agriculture has also always been in the innovation space. And I want to think that there was an article which pointed out the 50 inventions that have done most to shape the nature of modern life. And I put the paperclip down there because it's not one of them, but it certainly has had an impact on us. So here's a top 10: printing press, electricity, penicillin, semiconductors, optical lenses, internal combustion engines, vaccination paper, the internet, and steam engine. But then we start getting all of these that have to do with agriculture. So nitrogen fixation, refrigeration, the green revolution, Norman Borlaug, and feeding the world through advanced breeding technologies, the cotton gin, pasteurization, plant breeding in itself. Remember the monk Gregor Mendel, who studied peas, really led to the whole beginning of what we now know as biotechnology and understanding genetics, and the self-propelled combine harvester. Now the moldboard plow, you see the 30, that really was a simple innovation. It was an innovation which said a plow goes through the soil, and instead of just plowing the soil, it turns the soil at the same time. It does two things. It's easier to push that plow through the soil, and because turning it makes it easier to plant. And you know who invented that? Thomas Jefferson. So he went over to Europe, he found that plow over in Europe and came back and adapted it here in the United States. He was a true innovator. It may be simple, but it is on this list of things that changed the world. So when we think about innovations and what we're going after today, no idea is too small, right? Every idea can have major impact on our lives. And one of the reasons why we as an organization and other organizations love the idea of crowdsourcing solutions is because you never know where those great ideas are going to come. And in the world of data, crowdsourcing is the way you guys work. All these hackathons that we were talking about earlier this morning, they're really letting the best and the brightest come from whatever source they come from to work on issues. And we need more of that in agriculture. So I'm really happy when I hear hackathons about agricultural problems, when we can bring farmers to the table to say, here's an issue I have, and then crowdsource solutions quickly is one of the best ways, I think, of approaching problems. Now, the other thing about agriculture sciences is that our research is implemented more quickly than any other type of science. So on average, agriculture, you can impact agriculture productivity in as quickly, on average, as 2 years. So you know that many of you that work in agriculture, you may be working on a new production practice or a new way of cultivating a crop or something out in the field, and you literally can do some research. It's out getting tested in the field a month later, and then it's implemented 2 months after that. So things can happen really quickly. But the impact can be felt for 30 years. In the case of the moldboard plow, it can be felt for 300 years. So you really see that how quickly. So this space that we're living in right now in agriculture is incredible. And it's one of the most exciting times to be in agriculture because although agricultural science funding has plateaued, we're seeing that there's more increased investment from venture capitalists. There's new investment funds coming in agriculture. There are tons of small startups that are surrounding agricultural issues. So it's a great time to be in ag. Many of our startups are dealing in the data space. That is one of the most common areas that our small startups are pursuing. So you know very clearly in this room that we're in the fourth industrial revolution, which is cyber and physical systems. We've gone from the mechanical to the mass production to the computer and automation, and now to the cyber physical systems and all the things that go along with it. And you can see there the unprecedented levels of data that increase our computing power. So again, in agriculture, we want to take advantage of this time in which we live. So big data is the big thing. This was at a recent conference about digital agriculture, and of course, big data was the number one in the word scan here that came across. The world generates roughly 2.5 quintillion bytes of data per day. That is just incredible to think about. And we regenerate all those data in 2 years' time. In the past 2 years, we've created more data than in the entire history of mankind. And that will repeat over and over again as we get faster and faster and more data is generated. So we're really, again, at this incredible time. Now, one of the things that we're also doing is we're making it cheaper and faster to do all the things we can do with data. And I just want to give you an example. Sequencing DNA has become 1 billion times faster and cheaper than it was in the past 25 years. You know that we're going towards the $1,000 genome. We really want to be able to map an entire genome of a person for $1,000 or less. When we began, if you remember, NIH and Craig Venter were in competition, and we spent $1.5 billion on our initial work in mapping the human genome, and it was estimated that a single genome cost about $500 million. So that's incredible. But what does a billion times, you all are in the data world, so you may have a better sense of this than I, but I always think about what does a billion times really mean? If you look at this computer, from when we started, and there's an old Mac there, to computers today, those are 125,000 times faster. So nowhere closer to a million, but we think about how fast computers are now compared to when we started. So Ed Buckler, who's an ARS scientist up at Cornell, he won the very first prize at the National Academy of Sciences for Food and Agriculture. About 2.5 years ago, the Gates Foundation and our foundation sponsored a prize, a development prize at the National Academy, like the Nobel Prize for Food and Agriculture, and Ed Buckler was the first winner. He works on vitamin A, work in trying to improve plant production of vitamin A. He used this great example to try to demonstrate what a billion times faster looks like. So if you can imagine, he has a 3.7-mile commute to work, and it takes him about an hour. So he walks this every day. If he walked a billion times faster in that 1 hour, he could walk to Pluto. Now that really does put into perspective what a billion times faster looks like. So not only are we generating more data, but we're generating it even faster and faster and making machines able to process data even faster than ever before. So in agriculture, this is the era of big data. We're seeing that there's all sorts of burgeoning fields in agriculture, many of which you already know very well and hear about, but new genetic technologies, of course, gene editing is going to open doors for the generation of more data than we ever thought, and it also is going to provide the opportunity to use data in ways that we never envisioned. Indoor agriculture, it's a growing field. We need to be able to screen plants and put plants inside and know what traits are important for those plants. And we're generating a lot of data in that way. Of course, precision agriculture and digital farming we've heard all about. Resilient agriculture, our ability to not only farm sustainably, but to do the next thing, which is to provide value to farmers for their great practices, is going to be totally reliant on data. They are going to have to be able to demonstrate, for example, that they have better ability to manage water quality, better abilities to manage soil health, to reduce inputs. All of that is going to be required for them to demonstrate and get value back for their good practices. There's huge intersection between nutrition and health. We were just talking about it this morning, that where we're going to have to understand animals and plants that we eat and that intersection with how it makes us healthier people. And of course, traceability. So traceability in this area is quite incredible. I don't know if any of you know the It Takes Two to Mango story with Walmart and IBM, but Frank Yiannis, who is the head of food security for Walmart, came to his staff 2 years ago and said, with a package of mangoes, fresh cut mangoes, and he said, I want to know where these mangoes came from. And it took his staff 6 days, 18 hours, and 26 minutes to tell him where those mangoes were produced. So at that point, they formed a partnership with IBM, and today they can tell where a particular product comes from in 2.2 seconds. So that is just an incredible use of data, an incredible use of blockchain, and all the new technologies that are getting deployed. This ability to be able to trace not only the origin of food, but things such as foodborne illnesses and where they come from are going to be so important in the future and totally reliant on data. So this is going to be hard in the back, but these are all the things that, and you heard many of them, I don't have to go through them, but we're using machine learning and deep learning for predicting weather and climate, which is one of the hardest things to do. All the automated equipment that we're using, we have automated tractors now. We have a new system, a tractor farm, where you literally can be a farmer and sit in your living room and control up to 13 a fleet of tractors in your field that are small and actually don't compress the soil so much. And you are able to do the same work, and literally you send that tractor through the field once and it learns everything about the field. And from that point on, it can do everything automated. Of course, sensors, all sorts of sensors for soil and moisture and nutrients and all sorts of things that we're picking up from the field. Smart irrigation technology, so with precision agriculture, we no longer manage by the field or by the row or by the plant. We can manage by the plant and we can manage by the inch. So you can tell your irrigation machines that have sensors, your irrigation technologies that have sensors where and when you need to irrigate and what part of the field, and literally turn it on and off at the appropriate spots. And then the whole part of the whole supply chain is being impacted by this. And understanding consumer behavior, you already know when you go to a store and you buy things that you then get coupons, which keeps track of everything you've bought in the past, and you get coupons for the things that align with your normal buying patterns. Well, it's so much more sophisticated than that now. I just heard of a new technology a couple weeks ago where if you buy local produce, when you get to the checkout line, you will be able to tip that specific farmer who produced that product. So this is an incredible advancement, but you have to know all sorts of things. You have to be able to trace where that food came from, know where that food came from, have an economic system, that financial system is going to be able to give that funding back, or those dollars back to the farmer. And then, of course, we trace everything through social media. Everything that you do is known through your social media patterns, and that pertains to food. Now remember, the interesting thing about food is that we as consumers and consumers of food have a very emotional response to what we eat. So that impacts a lot of what we do in agriculture. And the example is GMOs. We use GMOs every day. You eat GMOs every day, actually. But in the case of biomedical, GMOs are used routinely in the development of drugs. And most individuals have no qualm about taking medication that's has GMO or has been produced through GMO technology. But there's a lot of concern about eating GMOs, whether or not those concerns are valid or not. So because of this, it's very important to understand why people choose the food that they choose, because that's going to influence what we produce, how we produce it, how we make it available to consumers. And so we need to have all those data that are going to give us that accurate description of food behavior in the consumer. So I love this picture. I just found this of the robot actually standing out in the field. I don't think that's real, folks, but we have all of these different places where we're getting our data from. Those data are coming from tractors, robots, not this kind of robot, but other kind of robots, unmanned aircrafts that we just heard some about earlier this morning. Farmer input. Farmers will actually generate a lot of the data on their own, actually input data on their own. All of our research on genome and phenome, weather data, retailer consumers, and many more. So it's coming from all different sources. Now, one of the things that I heard at a recent conference was that agriculture of our major industries in this country, which is about our 5th major industry in the country, is the least disruptive industry. So that means that when you think about what is a disruptive technology, it really wholesale changes what that technology is about. You might think about automated cars and what they're potentially going to do. You might think about Airbnb. You can think about online purchasing through Amazon, which is really totally disrupted the system. However, agriculture is really good at adapting and adopting all of those technologies from other places. So when it comes to data and data technologies, we're some of the first to adopt them. And so the idea that we've been using information from GPS to do precision agriculture and manage our insects and pests on our farm has been happening for a while. Or that we have been using automatic, tractors have been automated for years. So we are very good at adopting those technologies. I would say, though, at some point we're going to get that technology that we're going to see in agriculture that's going to wholesale change what we're going to do. So here's an example of how all the things are happening in an agricultural system and an on-farm system. This is not taking into account everything that's going on below, but all of the smart sensing, the smart controls, the smart analysis, and then everything that's going in the cloud and all the data analytics and everything that go in and go back to help manage. Now, you know that in dairy farming, for example, many dairy farmers are now becoming robotic. That means that basically a human hand does not touch a dairy cow. It has a sensor on it which tells you a couple of things: what you should feed it, how much milk it produced. They actually go in, and all the technologies to put the equipment on their udders is all robotic. They get washed, they come out, they feed, and it turns out that if you let a cow decide when it wants to get milked, it's much more productive and much more healthy. So instead of taking it in 3 times a day, it goes in when it wants to go in and gets milked. So this entire system is going robotic, and it's totally dependent on the data and the valuable data that they're getting out that continues to let them evolve and manage the dairy herd in the most proper way. We're going to see more and more of this, and I will tell you that I would predict that by the end of 10 years, all dairy farms will be totally robotic. It will be very few human hands involved. But there are issues in agriculture. We heard some of them this morning from Aaron, but others that are going to be important. So we have a lot of challenges, the volume, the storage, the meaning, the compatibility, and ownership, and I want to talk about a couple of these. First of all, when you think about agricultural data that's being delivered or generated from the field, so you need a large amount of data in order to properly train algorithms. But remember what this data is like. You're in a seasonal, generally in this country, you're in a seasonal period where there's only data that are available once a year during the growing season. So you're going to have to make inferences about that. You're not getting a continuous push of data all year round. That means that it might take years of this seasonal data to have a significant temporal data set about a given farm or a given field. So it's just not natural that it's going to happen quickly, but we have to figure out how to do that. And then we need a lot of cleaning up, right? And many of you work on this area, whereas you need to, before it can be reliably used in an AI, it has to be cleaned up in some sort of format. Secondly, and it is true today that cell phone and internet technology connections may still be spotty on farms. So we may be generating data and moving along very happily, and suddenly we have an outage, then because they're in a very rural area, remote area, then those data lose their power, right, because you have gaps. We also are somewhat victims of our own interest in agriculture. We have, as I mentioned, all these startups that are happening. And they oftentimes are starting up, a big area, of course, is data and decision support. So give farmers more information using their own data, and give them decision support tools to tell them when to plant, what to plant, or how to manage their herds, or et cetera. But oftentimes, these small startups are using data where there's lots of data gaps, or there's not the infrastructure or the warehousing structure that you might have in Silicon Valley out on farms. So we need to build that. We need to make that stronger. And the other thing is that big companies spend years doing field trials to validate these things, where small companies and startups may not have enough field trials or may not hook up to really get those applications going in a way that are totally verified by the field trials. Now, if you're a farmer and you're trying to decide on whether or not to take those technologies, they're getting marketed for what these technologies can give. They don't know all the background to these. So is a farmer going to take the risk? Remember, a farmer, it's a high-risk industry. Their very livelihood is dependent on their success, and their very livelihood is also dependent on external factors that may not influence them. So they may not want another external factor that they don't know the veracity of that particular precision support tool. And then, of course, we are very interested in some of these issues in agriculture because of agricultural research. This is an example where we want to know more about the phenotype-genotype associations. So let's say that we want to know how crops perform in various climates and what characteristics or traits they have to allow them. And we want to develop a probability model that will tell us which genes are most likely to contribute to those traits, right? We have millions and millions of combinations that we potentially have to look after. So we need advanced software to really be able to do this. We're interested in this, in AI and deep learning and the interactions between genetics and environmental control. That is one of the biggest areas in plant biology right now, is to really understand these complex genes, but we really have to know how the plant is responding. So we need data and computational models and tools in order to be able to do that. I want to talk, I'm going to go back in just a second, but I want to talk a little bit about the issue we talked about this morning, which is data ownership. So in the world of agriculture, data is a commodity. And there was a question asked at a recent meeting, is whether or not farmers will get paid for their data. Right now, in many ways, farmers will generate data, and those data are generated by companies, are used by companies that collect those data. And then those data are managed and given back to the farmer. And those data are sold back to the farmer. So we oftentimes have very integrated systems in agriculture. You have a farmer who will not only buy their seed and their chemicals from a specific company, but now they'll buy their crop consultants and their data analytics all from that same company. And when that happens, who owns those data? So the company is making use of them. The company's selling them back to the farmer, actually, as a service. But does the farmer still own those data? So that's a huge question. And secondly, farmers have major concerns about this. I mean, a farmer will more readily give you, as academic researchers, access to data than they will to other organizations such as companies and or the government. So there's a lot of things they're concerned with. They, first of all, don't know really how those data are going to be used. They have competitive concerns. This is a big issue that drives farmers. Farmers are competitive, and while they work together often, they are concerned that they're in this cutthroat world in agriculture where profits are very small, how they're doing against their neighbors. And they're fearful that if their neighbors know something about their farms through those data that they're making available, either publicly or to the companies, then they lose their competitive edge. And the other real concern, we heard it here about government. If those data go to the government, can they be used against the farmer for upping regulation or saying, hey, I discovered through those data that you're not complying with this regulation or that regulation about water quality or something like that. So they're concerned about that. And so one of the things that I will stress for us is that working with farmers to find that middle ground of where we can use those data but still have them trust us in how those data are being used is so, so important. The other thing that we're thinking about is how, with this constant generation of data, and remember, I was impressed at NIH with the amount of big data. I mean, it was incredible. We started the BD2K program at NIH, the Big Data to Knowledge. We devoted $200 million a year to the BD2K program that's still going on. And now that I'm back in agriculture, I think, boy, that's small data. I mean, that is one animal, the human being. In agriculture, we're talking about the sky, the weather, the soil, animals, plants, humans, economics, everything that's involved with it. I'll tell you, folks, those are big data. Not what we have in the biomedical, and really, that's not true. It's all huge in biomedical as well. But all those issues, imagine what we're learning in a human could also apply to a swine or pigs or all of those kind of, or cows in the same level. So the data here are enormous. So one of the things that we have to think about as a community is how we create platforms that don't generate new data. I mean, if we're constantly collecting data and then generating new data about those data, then it just gets even larger and larger. And then we also have to make meaning of big data and make big data conclusions from smaller data sets. So how do we do that? Now, sometimes those data are getting so large. So one of the things that we're doing as an organization is, oh, thank you. I don't know how that changed, but thanks. We're exploring areas where we are bringing together multiple agencies and the private sector to look at next generation data mining, because giving and data mining algorithms, giving meaning to those data that are either large, so large that we have to find new ways of looking at them, or small data sets that we can get those big data conclusions from is going to require new kinds of algorithms. If you think about what's happening in China right now, I am a big proponent of work across the globe in agriculture. This is so important. Science done anywhere is important for science everywhere. And so I wanted to just put that out there. And of course, scientists have nationalities, but science doesn't have any nationality. But what's happening with China, and remember, China now spends 3 times as much on agriculture research as we do in this country. They have incredible facilities. For example, they have more sequencing capacity in their one warehouse than we have in the whole rest of the world. So what they're doing is they're going around the world and getting all sorts of field data about agriculture, including phenotypic data, field trial data. They're going back and having all the sequencing data that they can possibly imagine about every organism on Earth that they've sequenced. And when those two things combine, they have a massive data set there that is going to be so large, and not that they're going to hide it, they will let it be accessible, but we're going to have to find new ways to do it. And our strength in this country is the things like algorithms and our data analytics. That's what's going to take us to be able to use those data and get them available for agriculture. So we're putting together facilitating a discussion first with the federal agencies, and then we will have a broader discussion with you in the community to see how we can advance research regarding next generation data mining algorithms, particularly for agriculture, but across all areas of science. And we want to harmonize our efforts in this way so we all move with one voice. So these are the agencies that are working on it. USDA, both ARS and NIFA, at NSF, SCIENCE, and BIO. DoD through DARPA, and I'm sorry, that should be ARPA-E under DOE, DARPA, NIH, NIST, and ourselves. So we're having our first meeting on this subject in a couple months, and then we will go out broader to the community, because we want to say if we want to put out RFAs or potential challenges or prizes in this area, we need to work together to do it. So the other issue, of course, is open source. We heard about this, and I am so happy to hear about all the open source activities that are going on. In agriculture, to get over some of these data ownership issues, and that the commercial aspects are oftentimes are hard to get into these, into what's really happening in the private sector, we need more open source platforms. And I don't know if you know about GODAN, which is the Global Open Data for Agriculture and Nutrition, but this is a series of countries across the world that have come together to vow to have agricultural data open and available not only to scientists but to the public. We're part of this. We actually funded the last conference on GODAN. But we have a big ceremony at the United Nations where these countries will come together. This is how important this is to agriculture, that countries will come together to pledge to keep as much data open and available as possible. We've had a couple open source initiatives. We had a grant to Purdue to develop a community-based approach of converting ag data and algorithms into tools. But the bigger issue that we've been trying to put together is a multi-partner consortium on open source solutions to data management, where we can have an open source solution that we can attach other particular areas of decision support to, and have a small open source solution be a framework for making a larger nationwide open source, particularly concentrating on soil health, but going beyond soil health into this. We're trying to raise the funding for this as we speak. And then the other big issue for digital ag, of course, is the expertise. So we need a lot of people working in digital ag. And it's not simply the idea of taking a computer scientist and giving you an agronomy course, or taking an agronomist and giving a computer science course. Many of you at your universities had developed programs in digital ag, or at least emphasis areas in digital ag. We're trying to fundraise right now to raise a certain amount of money that we will match to create the Digital Agriculture Training Awards. I think many of you are familiar with NIH Training Awards, where you have an area of science where you can actually devote a large number of resources to develop and or adapt programs to train more in the digital ag or in a specific area, and we want to do that in agriculture. We're trying to create about a $10 million program, of which we would fund anywhere between 4 and 6 institutions to produce either undergraduates or masters or PhDs in digital ag. And so I could really use help with fundraising. I'm just about to embark on this. If you have ideas of groups that would be willing to support this, we have had a lot of connection with not only the Googles and IBMs and Microsofts of the world, but all of the big companies that have digital ag sub-companies and things like that. So look for more of that in the future. And so what's the future of this in big ag partnership? Really, what you're doing here with the Midwest big data hubs and the other hubs is really trying to bring people together around common problems and solutions. And in agriculture, this is so important to us. So we're going to share our resources, we're going to share our knowledge, we're going to share our risk of these projects, and then we're going to change the world. And that's how we're going to do it. But here is something that's so important for agriculture. Big data has led to more efficient farming, direct retail to consumer, new products, improved food safety, all of these things, value to the farmer for sustainability. But what is really happening is we see big data as a way to shift in the roles and power relationships among traditional and non-traditional players. So when I talked at the very beginning about farms that are viable farms, farm profitability has been at its lowest point in our history. Farmers are having a tough time making it. And you can be the best farmer on earth and still be struggling in this world right now. So we need to find ways using big data, data analytics, artificial intelligence that are actually going to bring value back to the farm. So if you think about direct sourcing to consumers, reducing the amount of middlemen, things like that, making farms even more efficient, those are the kind of things that are going to bring that value and help us sustain this incredible agricultural system we have in this country. And we're really relying on all of you in big data. If you don't work in agriculture, please come and start working on agricultural issues. They transcend all the disciplines, right? So please come and work on them. We need you so badly in this area for the future of agriculture in this country. And most of all, we need to gain the trust of farmers. That is pivotal for us to be successful using big data and data analytics and digital agriculture to make a better tomorrow. So let's work together, and I'll be happy to answer any questions you might have. But thanks so much for having me.
So we have mics going around the room, and we have about 10 minutes for questions.
Hi, Brian Yandel from Madison, Wisconsin. I'm a professor in statistics and horticulture, so I've been working in the agriculture area for a while. And one thing that I really enjoyed your talk, but a lot of it seemed about scaling up, the challenges of scaling up and about efficiency, but I'm wondering about the issues about data models and effectiveness, because as you scale up data, the kinds of models that you developed in a small scale don't necessarily scale up. And there are bias issues and other things of that nature. I wonder if you could talk about that a little bit. And developing models is not easy, as you know.
Yeah. So we actually have it's a great point, and it is very complicated, and particularly in the world of biology, when you start scaling up models from all the way down to the cellular molecular scale, all the way up to the whole plant. So we have a project at University of Illinois called Crops in Silico. And basically what Crops in Silico is crop modeling on steroids. And what they're trying to do is to take crop models, roots, leaves, plants, growth, bring them all together and to be able to predict outcomes like they never would before. And they have to take into account exactly what you're saying, how these things are going to scale. They've had quite a bit of success. We're going to fund it with the Gates Foundation at a larger scale, just starting quite soon in January. So we're well aware of that issue, and we're hoping that the Crops in Silico model can really work and demonstrate some of the issues and try to overcome some of the issues of scale. If you think about the Crops in Silico, what it really means is that if you did it right, you could go after a new trait and never have to do a field trial. If the model really worked, it could tell you exactly how that crop with the new trait is going to respond to a soil, to a production practice, to weather, et cetera. And, but of course, that's a long way off. But that's really what that's about. So modeling is really important. We do a lot of work in the modeling area, and that's been a pivotal point, one of our centerpieces.
Hi, Hamid Akpia from Indiana. I want to ask a question about your last slide about the fact that farmers are struggling, and one of the things that we can do is to eliminate the middleman.
Maybe. And not in every area, obviously.
Yeah, but I think we seem to be facing a paradoxical situation where actually we are adding middlemen. But you gave examples of the data being given to the companies and then sold back to farmers and so on. And I wonder if you have any thoughts on that. How can we avoid this kind of paradoxical scenario?
Actually, avoiding the middleman is something that in developing countries is actually one of the ways that they're trying to increase farm profitability in developing countries. Because in developing countries, farmers make so little money that they're barely able to feed their own families oftentimes. So one of the things they do, let's say a coffee farmer, they will train the coffee farmer of how to roast coffee. And then that farmer will take on that part of the production as well as growing the coffee themselves. In our country, it's a lot different. Now, we do have much more local growing of food. The other thing that we're very interested in is how all the distribution and logistics and how you conduct what we call urban agriculture, that's agriculture closer to big urban environments, not necessarily indoor agriculture, but just agriculture in general. So that's one thing. But you know, taking out the middleman in this very structured agriculture that we have is very difficult. But one of the things that happens is we have processed food and we have more and more processed food, and that's one of the yins and yangs of this whole problem, because of course you need a middleman for processed food. But some of the things that can happen in this area that will raise value is to raise have farmers grow more high value crops. And one of the things that we need big data in order to do that is that we need to understand the nutrient content of food and what nutrient content consumers want and how we produce that nutrient content through the whole supply chain. So how we produce it on farm by changing the kinds of kind of crops that we produce, or how we produce a crop, how we process that food, and then get it to the consumer. So you can imagine that if we really need food with more vitamin A, and a farmer can produce a crop with more vitamin A, they could get more value for the crop. So we're looking for high value crops. That oftentimes is hard for a farmer to do. They traditionally are embedded in their kinds of crops that they grow for their environment, for their soil, for their equipment. So converting a farm to more high-value crops can be a difficult proposition. But those are the kind of things we have to look at, and how we can use large data sets to help us do that, to understand consumer desires, understand processing needs, understand distribution, understand nutrient content in plants, and how we raise nutrient content, all of those kind of things.
There's another question.
Hi, yeah. I had a question. I guess it's kind of related to what you just described. You know, you talked about who controls the data, and, you know, in terms of producing high-value crops, I think an important part of the emerging data story is how crops can be more bioengineered. And it seems like a big, important data holder in that whole ecosystem that I never hear talked about, you know, are the people who own or hold patents or data rights for phenotypes or genotypes. You know, you hear these stories on NPR or Monsanto with the warehouses full of, you know, where does that fit into this whole ecosystem? And how do you even combat something like that? And why is it never talked about?
Well, it's talked about a lot, actually. I mean, in our whole area, you know, we had the Myriad case that NIH actually were the defendants of about patenting genes, which we won at NIH, so you can't patent a gene. But yes, you're right. I mean, everything up to the gene you pretty much can patent, including development of traits. But, you know, one thing about gene editing, or CRISPR-Cas, is that anybody can do it. You know, you can do CRISPR-Cas now in your garage. I mean, you can do it. It's a little scary to think about, but almost anybody can do it. So in some ways, that is freeing up our society and a little bit about being able to do this. But you're right. This is another big part of the entire infrastructure of agriculture, about who owns the intellectual property about plant traits and animal traits. And that's something we have to overcome. But I'll tell you that one thing that's happened in the private sector in agriculture is that most all companies now have a huge sustainability and program, so they work on environmental issues. And in fact, one of the big drivers of improved environmental practices in agriculture has been the food companies, because they require, who they source from have to meet certain standards. Same thing with like McDonald's, who they source with only antibiotics, you know, about antibiotics and some of that. So the food companies are oftentimes drivers of sustainability, but they also have big humanitarian programs as well, and those feed down all the way to the science that they do. So the companies tend to be more willing now to share data, and that's why we've been seeing more willingness to join our consortia than ever before. They're more willing to share data. They share risk when they do that, but also because of humanitarian reasons, they want to get them all. They all have international programs where they share genetic material and germplasm with with developing countries in order to be able to feed the world. But yeah, I think that's a big issue. But we do talk about that all the time. That's not a small issue that's not talked about. It's a big, huge issue.
I think there was a question in the back, yes.
This is Robin Shoemaker. I'm a program leader in economics at NIFA. And you're touching on all these kind of issues that economics has an important role. Property rights, ownership of all these type of resources, whether it's physical or virtual, the complexity of the supply chain, the introduction of new products and processes have market impacts that affect prices and incomes and so on for producers, consumers, and welfare distributors, which way, and all these kinds of complicated economic problems. So I'm wondering is do you have or ask for economic research component as part of the projects that you fund?
We do, and that's so important to us. In fact, we've been a big proponent. One of the things that happens in agriculture is that we change practices, or we have consumer demands that we meet without really knowing all the trade-offs, including the economic trade-offs. I'll give you a great example. Cage-free eggs. Cage-free eggs are not actually cage-free. It just means that individual chickens are not in an individual cage. It was done for animal welfare reasons, and that we created an enormous animal welfare program and problem when we went cage-free, because chickens are very aggressive birds, and they fight, and they have this problem called piling, where one or two of them will start fighting and get in a pile, and up to 100 of them will jump on this pile, and they all break their keel bones. And in them, when they have broken keel bones, they have reduced, they're in pain, obviously, and they have reduced egg-laying capacity. So we created this, and the entire industry said, we're going to move here without understanding the economics of it, and not even understanding whether consumers really wanted that. So we did two things. We started a program with the poultry industry to try to increase bone density and bone strength in birds, but at the same time, we did an economic study to see whether or not people wanted to eat cage-free eggs. And in fact, they do up to a point. And after a certain point in cost, they will not even buy eggs. If your only choice is cage-free at this price point, you're not going to buy eggs. So those economics are so important to us. And the data in the whole supply chain that allows us to do those economics is really critical. In fact, I'm trying to hire an economist right now for my program. So we do believe in that. Economics is such a big part in agriculture that it can't be overlooked. It's a science. And so we work on both social and physical and biological sciences, and the social sciences of both human behavior and economics. So it's very important.
So
And then that last
one.
Oh, hi, Sally. Brian Athey. Good to see you. University of Michigan and Big Data Hub. I really appreciate you taking the time to spend a little bit talking about what's happening in China. I've visited the National China Genome Center and BGI in Shenzhen.
It's incredible.
The incredible. If everybody should be aware of this, what they're doing is they're blowing us away with this.
They're blowing us away.
It's just absolutely orders of magnitude more than what we're doing here. And so there's an asymmetry starting. And I really think we do need to think about bilateral cooperation and, any way we can help with that. I spend a lot of time over there, and I'm not so confident that they're going to let us. I do a lot of biomedical data processing in China, and we can't move one bit of data over here to process it. So it's kind of a wall between us. So anything we could do to work on that together would be.
So and in fact, we have a program at the University of Illinois called RIPE, which is Rapid Increases in Photosynthetic Efficiency. We're also doing the Gates Foundation. That is China as a partner. We believe in having China as a partner. They're so strong. I think our strength is analytics, and I don't want to say we hold it over the heads of the Chinese, because that's not how we cooperate, but you're absolutely right. We have to cooperate with them. We cannot be in this adversarial. Now, it is a problem because in the government, there's actually, many movements afoot to not allow federal agencies to work with China, which is really problematic in my mind. And the issue about visas, having Chinese students come over, for example, at NIH, where we had tons of Chinese students who come over, it's so important to us. So we cannot throw the baby out with the bathwater. I mean, but we are facing roadblocks, I will tell you.
Yeah, there's absolutely no question about that. So let's continue to get this conversation and keep it going. It's so important.
And I think in the area of data, this is an area where we can collaborate and show the strength of both sides and for the common good.
Yeah, I think, you know, China has a program for machine learning and artificial intelligence where they want to have domination in 2025.
And they'll get there.
And they're going to get there. I mean, they're making huge investments in this. I visited Tencent World Headquarters in Shenzhen and have seen it firsthand. They have a market cap bigger than Google. Yeah. And so it's just an interesting and important time for us, especially with all this soybean stuff and everything else going on.
We're starting a consortium called PIP, which is Precision Indoor Plants. And Japan and the Netherlands of two of the big indoor plant, or the indoor agriculture are big, but China's going to join with us. They bring in a lot of the data that we need as well. So we're happy to have them. So we'll have a trifecta, and Australia is joining too. So we're going to have a very international program, but we can't exclude China. Cannot exclude China. Thank you so much.
Yes,
really
thank
appreciate
you.
it.
Let's join me in thanking Sally Rocky. Yes, that is an amazing.
When you guys sit there, I will. I'm going to do 3 minutes. Okay. All right. So we're going to move directly into our next panel. I'm Bill Gropp from the University of Illinois again. And this panel is on AI, data, and ethics. I'm, in fact, looking forward to this. I find there's a lot of interesting discussions about even what AI means and whether it's a reasonable term. It certainly is the term that is used, but a number of people have looked at the question of whether artificial intelligence as an intelligence by artificial means is the appropriate term to even help us think about the consequences of the technologies that are labeled AI and how they impact how we interact with the data, how it interacts with us, the impacts that they have on us. So this panel is going to consider the role of academia in AI research, education, and leadership, the implications for data, and so that's not just the collection of the data, but the quality, its security, its governance with respect to developing what I'll go ahead and call AI-based systems and services, and particularly the opportunity for academic industry partnerships for AI systems. All of these things are very relevant to the missions and goals of the big data hubs. Another thing that was interesting as I was looking over some of the recommended reading for the panel was work that has already been done looking at the complexity of these issues particularly in terms of fairness, and the fact that there are already a couple of negative results that argue that certain very reasonable measures of fairness are mutually inconsistent, which also calls to mind Arrow's theorem, which is particularly relevant today. As Arrow's theorem says that under certain conditions there's no voting system that everybody will be happy with. So on election day, I think that was a particularly appropriate reminder. And so with that, let me introduce our panelists, and then I'll introduce all three of them, and then I will give them about 5 or so minutes to make a brief statement, and then we'll start with questions. Really encourage you to take advantage of this time to ask questions of our panelists and to help stimulate some discussion, and we'll have some time after the panel to continue that discussion. So our three panelists, first panelist is Julia Stojanovic. She is an assistant professor in the Department of Computer Science and Engineering at the Tandon School of Engineering and the Center for Data Science at NYU. Her research focuses on responsible data management and analysis practices. Our second panelist is Jana Diesner, who's an associate professor at the School of Information Sciences at the University of Illinois, and her research is in social computing, human-centered data science, and responsible computing. And our third panelist is Hamid Ekbia, who is a professor of informatics, cognitive science, and international studies, and is director of the Center for Research on Mediated Interaction at the Indiana University. And with that, let me start with Julia.
All right. Thank you for having me. It's a pleasure to be here. And I only just arrived this afternoon in time for the wonderful keynote. And as I was starting to listen, I was really getting nervous about how relevant the message that I bring will sound to this audience. Because what's more important than food, than agriculture, right? And seemingly, actually, the case that I'm going to discuss is not very related. But as we will see, many of the concerns, many of the challenges that arise in digital agriculture also mirror the case that I bring, and that is from smart cities. So there's actually a lot more of a common ground than meets the eye. So what I would like to discuss, and just in the way of background, I'm a computer scientist by training, and I was happily working on data management problems having to do with efficiency and accuracy of various methods on the large scale. And then at some point it became apparent to me and to my colleagues that we're now in a new stage of data science, of big data. I'll use these terms interchangeably. So we used to be really concerned about what we can do with data. How quickly can we process large amounts of data? How accurately can we do this? But now that is all solved. Well, of course, it's a challenge still, but in a way it's solved, right? So really what we need to think about today is not what we can do with data, but rather what we should and shouldn't do with data. And this, to me, is the top-level framing of responsible big data, responsible data science, data ethics, of which ethics in AI is a kind of a component. It's a subroutine. So in the last year or so, I've started working with New York City on a very important initiative. New York City, in December 2017, passed a law that compels city agencies to be transparent and accountable in their use of algorithms and data. So we don't have in the US a law that is similar to the GDPR, the General Data Protection Regulation in the EU. And in fact, New York is actually the first city in the US to have passed any law that has to do with data and algorithmic transparency and with data rights of subjects. So what this law compels the city to do is to form a task force that will then provide a report with a set of recommendations on how individuals can interrogate city agencies about particular outcomes that are relevant to them. So for example, if my son is given a spot in a particular school, I need to be able to ask and get an answer from the Department of Education of New York City how the decision was made. And why wasn't he granted a spot in another school, for example, that I may have preferred? So that's one aspect of this. Another aspect is that city agencies now are accountable to not discriminate against demographic groups based on membership in protected groups, based on protected characteristics such as race, gender, disability status, etc. So again, an individual or a representative of a group, such as a community advocate, can come to a city agency and interrogate whether, in fact, their treatment of the population of New York City is equitable. And the third component of this law is that agencies need to actually proactively make available to the public information about where they use algorithms and data to make decisions and how these decisions are made. So what data is being used, for example. They need to be able to allow the public to see a record of the program and of the data that the program uses to make decisions. So these are all tremendous challenges that the task force that was appointed by New York City Mayor faces. And I am fortunate to also be a member of this task force, and it's really been an incredible experience because we have on the task force external members such as myself. Some are technical computer scientists, some are people with information science backgrounds, others are technology lawyers, and then there are also many representatives from the city government, from the Mayor's Office of Data Analytics, as well as from various agencies such as the NYPD, for example, and the Department of Transportation. And so we as a group have come together to try and understand what the city can do to really make this law stick, to really allow the public and individuals to interrogate how data and algorithms are used to govern. And it's been incredibly challenging from a cultural standpoint, as well as from the point of view of just the basic research and the technology that would allow an agency to be transparent is lacking. So we in the research community really need to step up and to start working on these very important problems. So maybe this is 5 minutes or so? I mean, I can continue talking and I can talk about this for hours, so yeah.
It's actually perfect.
Great.
Hamid?
Okay, thanks. I'm glad to be here. My presence here happened rather surreptitiously, thanks to my colleague Ina Cooper, who is here. But I'm very glad that I'm here. I learned a lot today so far about agriculture and among other things. But I want to just use this moment and remember a good friend who just passed away 2 weeks ago because he was very related to many of the institutions that are represented here. His name was Les Gasser, and he was at the NSF for a few years and then at the University of Illinois, which is the organizer, and he unfortunately passed away just 2 weeks ago after a long battle with cancer. And I just wanted to use this moment to remember him because of our friendship, but also because he would have had good things, important things to say. We've had long conversations with him about what he called the life cycle of data and so on. And I think that was a useful concept that he never got the chance to develop. But anyways, my approach to these questions of AI ethics and data and so on is from the perspective that I call the political economy of data or AI, especially in relationship to labor and value. One of the things that we have noticed in the last couple of decades is that there's a change of paradigm in the sense that in the past, what people ask what computers cannot do so that what humans are not willing to do or what they are not able to do so that we can leave that to computers. Jobs that are boring or, or dangerous and not doable simply by human beings. The change of paradigm somehow flipped that in the last 20 years roughly, or less than 20 years. And it is roughly the opposite, that nowadays we ask what computers cannot do so that human beings can fill the gap. It's a very interesting but alarming development. I call it heteromation, but whatever, as opposed to automation, meaning having others do your work. But whatever we call it, to me, it's a very important development because what it does, it shows us how much value, economic value, is created in the current environment which is not considered work, rather it is labor. That distinction between work and labor is a very good starting point, because we often think that economic value is produced in working environments. Nowadays, the majority of people, just us, are producing value, economic value, without being rewarded for that value. It is not considered work because it's obviously, most often it is not work, but it is labor in the sense that it produces value. And data, as our keynote speaker pointed out, big data is crowdsourced, but it's not necessarily crowd-friendly. It is, a lot of it is produced by people, farmers, but also users of Facebook and Google and whatnot. But the benefits do not necessarily go directly back to people, to the crowd. And that's something that I'm very interested in. And I think the origins of this goes back to the kind of question that we've been asking, especially the AI people themselves. The question essentially for the last 50, 60 years by AI was that what can computers do? Can computers do X? X being, can they think? Can they understand? Can they talk or converse? And now more recently, can they socialize? Can they feel? Can they, create romantic relationships between human beings? And so on and so forth. And I think that is the wrong question to ask, because there's no way that we can decide that question. It's a moving target. And as you know, if you follow the history of this, between the opponents and the proponents of AI, people have not been able to come to an agreement on this, because it is changing all the time. So the right question for me is not to ask what computers can do or whether or not they can do it, is to ask, what does it take for computers to do X? By what does it take? I mean, how we should change our ways of life, our ways of talking, our ways of knowing, and so on, in order for computers to be able to do X, whatever that X is. And I think that change of question, as simple as it sounds, is going to shift the way, not only our research, but our resources as well. Because then resources are going to be allocated differently. And the case of agriculture is actually a case in point. I think you can name any other application domain and consider changing the question rather than asking, can computers do this? Asking, how should we change things? But, in order for the computers to be able, or for them to be perceived, actually, as doing this. So that is my basically angle on the question of AI and data, both of them. I just want to end with a specific question. I'm working currently with a group of lawyers in the UK who are interested in antitrust and also in the question of what is called algorithmic collusion. Can computers collude? Meaning, can they come together and collude on pricing without human beings being involved? And my angle, as I said, is to change that question. That's not a question that you can meaningfully answer, because the meaning of collusion then has to change. And law is not prepared to do that, because this is a history of 150 years at least, where lawyers think in a certain way about collusion, meaning often having to do with communication. Well, computers can collude in principle without communicating with each other. Is the law willing or ready to change the definition of collusion in order to deal with this question? So let's not even ask it. Rather, ask, what does it take for computers to collude? And that is going to lead us, to very different sets of other questions, such as, for instance, what does it mean for companies to be allowed to do dynamic pricing or algorithmic pricing, right? Or what does it mean for them to let algorithms make these decisions, like many other decisions? What does it mean for the economy, basically, to be based on this kind of arrangement? Why not just think very deeply about a different kind of setup where none of this is going to happen? So that is roughly my take on the question of AI and data.
Great, thank you.
Hey, hi everybody. Thanks for having me here. I'm glad to see you all here. So I come to this question of AI and ethics and compliance from a very practical angle. the question that I'm often facing is, how can we comply with the vast amount of regulations and norms and expectations that is out there and still innovate? I'm at the School of Information Science at the University of Illinois. I'm running the social computing research lab there, and we use a mix of machine learning, natural language processing, and network science together with theories from the social sciences, humanities, and linguistics to basically try to better understand communication-based and interaction-based systems. And as part of that, or as a byproduct of that, we tried to, or we started out by trying to basically considering all the regulations that are out there, which is not just the IOB, but a lot of other things like terms of service, privacy, regulations, security, personal norms and values that people bring to the table, copyright, fair use, all of these things. And as we were way into that and tried to kind of understand what we are doing there and how that works, we also started to collaborate more closely with administration at Illinois, people from tech services, people from the CIO's office, everybody involved with regulation and policy around data to find solutions, good solutions for everybody on campus that allow us to do good science, offer cutting-edge teaching, and stay within the regulations that are out there. And by that, I don't only mean not breaking the rules, but actually doing the right thing. What does it take to not only be compliant, but actually doing and promoting responsible behavior? So that got us to do research, but also a lot of communication around the areas of data governance and responsibility. And by that I mean responsibility of computing with respect to research, development, services, and the workforce. Data governance has a lot of different subtopics and flavors. There's fairness, accountability, responsibility, equity, transparency, compliance, access, privacy, security, data quality, data provenance, all of these different things that are not owned or driven by any single one domain, but really a concern for everybody across domains, but also stakeholders in administration, in legislation, the general public, and so on and so forth. And the question there often is, how can we find good solutions in terms of bringing all responsible and involved stakeholders to the table, crafting policy, implementing policy in terms of processes and technologies, and developing the technologies and services that are needed for enabling and supporting compliance and ethical behavior. So I'll leave it there for an introduction.
All right, thank you. Okay, I have a few questions, but I'd also like to encourage the audience to ask questions. So while you're thinking of a few, let me start by posing to the panel. You all touched on fairly practical issues of dealing with data and ethics and responsible use. Are there, what would you say are the most difficult challenges that are faced in doing that? So, for example, is it the fact that these questions are very cross-disciplinary in a sense that many of us, goes beyond what many of us think of as cross-disciplinary, crossing between the humanities and the sciences as opposed to between a computer scientist and a mechanical engineer? Or is it something else that is the real challenge?
So I can start, right? So I don't think there is just the one real challenge, right? Of course, the interdisciplinarity is a tremendous issue here. And in responding to that, I'd like to also respond to your earlier comment in the beginning about there being negative results about fairness. So this is actually an example, right? So we computer scientists and technologists, we are used to having a definition and a ground truth and a kind of a single monolithic technological solution that addresses the problem that we have at hand, right? The answer is 42. I'm giving you a way to compute 42. But in society, things are very subjective. So I actually contest that it's a negative result, that there are several fairness definitions that are in opposition. This is something that we have to expect from a societal problem. There will never be a single fairness definition. And we as computer scientists just have to wrap our heads around that it's all going to be about trade-offs, right? So there is something that is fair from the point of view of an individual, something that is fair from the point of view of a particular disadvantaged group, something that is fair from the point of view of society. And there are ample examples that illustrate this and that can show us that really there cannot be a single answer. So I think here what's important is for us to come together as technologists and to say that solutionism won't work. It is not up to us to define a technical solution to society's problems. We have to work together with social scientists, with lawyers, with the public, to really understand how to make a solution work, even though there isn't a single definition of fairness per se, but also of privacy, also of transparency, also of data ownership, any of these things. And another aspect of why these are all such complex problems is that not only are things subjective, but also we're not dealing with a particular single algorithm, a single AI, a single box, but rather there is a notion here of a life cycle that is in itself ill-defined, but what we know is that it's iterative in some way. There are some algorithmic components to it. There are some that are necessarily going to be black box because we can't explain them. The data collection and data sharing component is really very complex. So it's the interplay of the data and the algorithm and the context of use that really make the issues very difficult here.
Just very quickly, I agree that there are subjective elements, but I also believe that there are strong, if you wish, objective elements driving this. And it is, we have to take the kind of the long-term view and look at this historically. Again, something that our keynote speaker pointed out, which is quite a surprise, that the lifetime expectancy in the richest country of the world is taking the opposite, kind of a negative trend. Where does that come from? How did this start? I think we have to go back and, ask this question, and I think it has to do everything with, with our economy and politics and so on and so forth. And I know this is not the space to talk about that, but I just wanted to highlight that there are strong objective elements to this. Going back to your question about, academic collaboration and so on, there is still this very basic fact that we live in silos, and academia is structured along these lines. We think differently, we have different methods and so on. And as much as we would like to think in multidisciplinary terms and cross-disciplinary terms, there are strong institutional barriers that have to be removed, by the universities in order to make this really work. Yes, we can talk, with each other, we can collaborate, but it's mostly, I think, I see this institutionally. And it is not going to, to work by just having, somebody from a technical background like me learn the language of law, and the other way around. It's deeper than that, so that's kind of my perspective.
All right, so the question was, what are big challenges we see, right? So coming from a public land-grant institution, one of the biggest challenges that I see and that I think we can actually solve, we together as a community, is education on every level, K-12, higher education, but also the general public, about what is AI, demystifying the whole thing, and reducing anxiety, if there is any, and I think there is some. The Brookings Institute had recently a survey on perception of AI on robotics in society, and I think we are prepared and we can do that. As part, for example, of our curriculum in data science in every discipline, and getting students prepared to the world we live in, where machines produce predictions and choices, and we as humans are basically there to make judgment calls and select choices. How do we do that in a responsible way? And what do we need to know in order to be able to do that? I think that's a question that could be considered in curriculums across disciplines, across colleges, and that we as a community could work together on to find solutions there. How do we get students ready to set objective functions against which machines will optimize, and that's what they do, right? And how do we educate people to set these objective functions and make choices in a responsible manner that basically provide us with human-in-the-loop technical systems where humans do what they are really, really good at and machines do what they are really, really good at. And together they can eliminate some of these biases that we see, where these biases are not biases in tech, these are biases often that exist in society, make their way into data, make their way into technology, and then these biases bubble up as outputs from AI prediction tools, for example, but they have a much deeper root somewhere else. And providing understanding of these cycles and processes, I think, would be a service to everybody.
Good. Okay, we've got a question.
Hi, it was a great panel. I was wondering whether or not how you would approach making policies about ethics in privacy and in data when there's such a changing culture in privacy and data. So as we all know from the Cambridge Analytics and what people are willing to put up on their own personal websites about themselves, there's really a very much change in, I think, people's attitude about what is private in their life and their data about themselves than what isn't, and particularly in young people. So how do you manage that with trying to develop policies when the culture is always changing about the very nature of privacy?
So society always changes, right? Democracy is never a done deal. That's kind of a meta answer, right? I mean, when we put technology in place, it is our responsibility to consult the public and to make sure that the public has a say in how technology and its use evolves. But in terms of privacy and perhaps more generally data protection, we do have an example which we may want to follow or we may want not to follow, but we should learn from, and that is the GDPR. And this is a very ambitious example with which, you know, the intentions are great. There are many problems in enforcing it. It's difficult, etc. I think one important issue here when developing data protection policies is to make clear how the data is going to be used and what are the benefits and the harms that the data owner, the data subject, will incur. So in your excellent example about farmers sharing data, right? The example is great because here farmers are both individuals, so they care about their own privacy, and maybe they don't want their neighbors to know that they failed, something of that sort, right? But they also are a business, and so they care about things like competitive advantage. So harms are from both of these angles. On the other hand, the kinds of benefits that we can derive, that a farmer can derive, can arise from a coordinated data analytics effort, right? So if people know what other people are growing, what's doing well, they can then decide on their own strategies. So this is a great example, I think, of where a community needs to really help inform these technological solutions and that are in view of the harms and the benefits that can arise.
Two very quick answers. One is in terms of the relationship between privacy and other ethical, if you wish, issues or moral issues that we are facing. I think privacy is the tip of the iceberg because it is kind of, you know, the front end of where we see people, you know, interacting with technology. But there's a back end to it. Actually, if you look at the process of big data, you know, data analysis, starting from the data collection and monitoring, to the mining and then, you know, to marking people and then finally, or classifying them and then finally, you know, controlling them or nudging them, whatever your favorite term is. There are different, very deep social dilemmas that we face at each one of these stages. Privacy is at the very beginning, which is why it is very visible to us. And everybody's talking about privacy. I'm not trying to say that privacy is not important. What I'm trying to suggest is that we have to see privacy in relationship to these other things. Namely, for instance, you know, at the second stage, where we are dealing with, the analysis of data and discrimination comes up. You know, when we get to the next level, it is the question of, you know, social justice, you know, data ownership in your example, for instance. Right, so I think my brief answer to that is that we have to look at this as a package. We cannot single out privacy and just deal with it, you know, as if it is isolated from everything else. The second part of the answer is that we have to look at this also historically. There's some intellectual work that needs to be done in order for the policy to catch up. Because our notions of privacy these days go back to the end of 19th century. That's old time, compared to the changes that have taken place. We hear nowadays that this new generation doesn't understand privacy. They just, they are very careless. I don't think that's the right answer. If you are putting the blame on the victims, which is not a good idea, right? So we have to ask, why is it that these young people are doing this? And that would be the good starting point. And I think part of the answer to answer that question, we have to revise our own notion of privacy as policymakers, as academics. Let's change that old notion. And that's why as I said, a lot of conceptual, intellectual work has to be done.
All right. So the original question was, how can we make policy, for example, related to privacy? And let's zoom out here for a minute. We are all very much in the technical details of these things, but it's a new thing. Facebook is younger than anyone in the room, I assume. It's a teenager. It behaves maybe like a teenager. So it's new. Let's go and figure it out. There's plenty of work to do, and I think a lot of people here are equipped to do some of this work. A lot of these debates that we hear are driven by insecurity, anxiety on all ends, of lawsuits, of long-term consequences that we can't anticipate, of changing legislation under our feet. Okay, so that's something we as researchers and scientists have seen many times and I think are ready to tackle. Knowledge can reduce anxiety and security. That's something we can bring to the table. We do see instruments and new solutions popping up, like the GDPR. Law often follows technology or is a little bit behind. Like the GDPR, for example, requires people or researchers, if they want to solicit certain sensitive types of information, such as your gender, moral beliefs, ideology, religiosity, and all of those things. Those are sensitive categories that need special treatment according to the GDPR if you solicit them from people. We don't need to ask people those things. They can be inferred from data. We don't need to have a survey to predict with high accuracy gender, for example. And it's not really clear, even in the legislation we have, how these things work if you don't ask them, but you basically infer them. So there's plenty of work to do that needs technical expertise, consideration of the public sentiment in general, but also deep technical understanding. And I think the biggest challenge, but also opportunity for drafting and promoting policy in this space is collaboration between all the different stakeholders that have something to bring to the table on change and legislation.
Thank you.
So can I respond to this? Sorry, because what's a panel if nobody disagrees? We have to disagree a little, right? So I'm going to artificially disagree just to heat things up. So the comment about Facebook being a teenager, teenagers don't govern and teenagers have parents, right? And Facebook's slogan, I think, is move fast and break things. And we have seen them break things, right? So there actually is an urgency to this. It's not just about, oh, let's keep calm and carry on and it's all going to resolve itself through education, which I agree with as well. But I think that there needs to be an urgency to this. We need to really understand that things are at stake that are serious and that we cannot allow teenagers without government oversight do things of the sort that Facebook and others have done. So that's my first thing. And also regarding using gender and other protected characteristics, whether you don't ask for them and you infer them from the data, but then your result ends up being racist, for example, or gender biased, you're liable, right? It's not on the intent, it's not on the input. Just to clarify for the audience, it's actually on the effect on the protected population that you're held liable as an organization. So whether or not you asked for race, you being Northpoint, the company that made Compass criminal risk assessment software, you still are liable for producing a racist piece of software for sentencing. So yeah, just that.
Okay. Okay, over here.
Hello, my name is Brian Ricks. I'm from the University of Nebraska at Omaha, and I do computer science. So I kind of want to follow on with that question. 5 years ago, the Xbox One came out, and it was going to have a feature where it would always have the microphone on, so you could talk to it and it would respond. You wouldn't have to push the power button. And consumers went crazy and said this is absolutely inappropriate. Having a device that always listens to you is an absolute no-no. We're never going to buy it. Okay, this was 5 years ago. It's 2018, and everyone is buying always-on microphones, and it's not just teenagers who don't care about their privacy, it's adults. So as a computer scientist watching this trend, to be totally honest, I'm shocked that as a society we went from 5 years ago, Microsoft has to apologize and change their hardware to take this feature out of the Xbox One, to we're buying the product we said we'd never buy in droves. So I'm curious, what has happened in those 5 years in society that suddenly we're embracing this technology we said we would never buy?
Yeah, this is too close to me. May I just jump in?
Yeah, of course.
I think we have, again, and we can do one of the two things. We can blame the adults along with the children and say how naive and stupid they are that they are doing this, right? Or we can ask, again, the historical question, how did we get here? And I think that's, I hope that we all agree that's the second approach that is more reasonable, right? It doesn't help to put the blame on the users, right? And that is a long, and stretched, conversation. But the type of environment, by environment I mean both economic but also cultural environment that encourages certain types of behaviors and imposes certain types of expectations on people. If you are, especially those of us who are not in academia. In academia, we do this voluntarily. We are 24/7 and so on. But in private sector, most employees are expected, especially at those who are called managers, are expected to be online for 24/7. They have to be responsive. If you do not play that game, you are hurting yourself in terms of the next step and promotion and so on. This kind of environment, which is there's no conspiracy. I'm not suggesting that a bunch of rich people got into a smoke room and then decided that they want to do this. But it's a historical process. And it is very interesting to watch how this has changed not only in terms of this, in terms of the microphones in people's homes, but in the last 100 years in terms of the ideal person, that we all imagine, right? The ideal person 100 years ago when our parents went, to work, and these were the people who were, behave rationally in the sense that they left their mess at the door when they went to work. And then at 5 p.m., they left work behind and went home, right? That was a clear line between these two. And we can ask the same question as you asked about microphones. How did we get here from that ideal image, right? He was a good citizen. He who leaves work, at 5 and goes to family is a good citizen. To who he or she is a good citizen nowadays who goes to, home and doesn't leave work behind. And how did we get here? So I think to me, the answer is obvious. This is a social economic process, cultural as well. I think it's very complex, but that's kind of my way of thinking.
So I think it's actually quite simple. It's the benefits versus harms, right? So I'm from Russia. And in the Soviet Union, the TV watches you, right? So there are no benefits to you, only the harms. And then in your Xbox example, there may be some perceived benefits to just the, male, teenage, or whatever, lower 20s demographic. So still the harms sort of outweigh. But now the technology makes it so much more convenient for us, right? So I just think it's a utilitarian kind of a thing. And it's, we as a society, we as researchers perhaps need to demonstrate to the people who are now seemingly comfortable with the benefits-harms trade-off that, yeah, harms are serious, if they are, indeed.
Okay. Other questions?
I'm thinking about what's happened in the last 50 or so years with medical information and medical data. So it used to be, back in the dark ages, you went to the doctor, he was an authority figure, you did what the doctor said. And for example, your tissue that was taken on biopsy or during surgery would be preserved and then used in for lots of research. And in fact, the HeLa cell was one of the most important model systems when I was in graduate school and for many, many years since. And now, in the last 30 or 40 years, we've seen the rise of more patient input, is I think how it's often phrased. Patients ask doctors questions, they go to Dr. Google, they've become much more sensitive to the distribution of data and tissue derived from them. There have been lawsuits over HeLa cells. We have a HIPAA Act now that I vividly remember caused a lot of frustration and concern among my biomedical research colleagues when it came in, and somehow it all got smoothed over and research has gone on. So, and we have things like not just Medline and PubMed, which many lay people use, but also Medline Plus and the rise of internet doctoring websites like from Mayo. And maybe Cleveland Clinic, I don't know. So I'm wondering if that experience is not instructive here. People in the beginning didn't assume that their medical information was private. They had a one-to-one relationship with their physician. That broke down. Then there was a backlash, if you will, about privacy of information. Information now comes from multiple channels. People feel more empowered about their information, and it turns out actually that patients usually have better outcomes if they can participate in their care. Seems to me that that is an instructive precedent in this situation. Instead of saying, well, we need to educate people. Well, yes, of course we need to educate people, and we need to help them see the trade-offs. But often so much of this is so far down and so far removed from them, they have no idea what happens when they talk with Alexa or Siri, right? And to the uses that that information could be put, and they have no control over that. And I think that a lot of that is starting to help feed this deep discomfort that we see. So I'm wondering if there are any lessons or precedents there that would be helpful in this discussion.
Yes. let me try to provide an answer here. So the medical field is one of many where the same thing happened. Information went from a very private one-on-one interaction where notes were taken on paper to a many-to-many democratized or pluralized space where digital information on individuals is available to many other people, often with some sort of an opt-in fashion. And how does that make people feel? I completely agree. There are questions around credibility and trustworthiness when people go and look for medical information online. How do you know what information is valid, which information is scientifically justified? How do you know what you can trust to some degree? That's a data literacy question. The other aspect I heard in your question was the notion of agency. How strongly do people feel empowered to own their data, act on their data, and manage their data? And that's something new to us. We used to think of ourselves and the things we have in terms of objects. This is my notebook, and there's my laptop, and in Champaign there is my apartment. And now we have this data me, where we are also all of our data, but it's completely unclear where that ends and where these boundaries are and what that means and how I own this and how I can act on this. I'm not sure if I have a good answer to that, other than that it's an educational process that requires the consideration of the general public's attitude on this and helping people to feel empowered and informed about where their data are, what they can do with it, where it goes, and how trustworthy data aggregated from the public online is, and how to, in a confident way, be able to interact with that.
I'm not sure if this is going to make sense, but and I have to be brief. But I think the health story is actually one of the good stories to be told. That it has to do with the democratization of knowledge. People can, get not only feel empowered, they are empowered to go to other sources. It challenges, the absolute power of doctors, which is maybe good in some ways and so on. The problem, if there is a problem, and there is a problem, is that we embed this in a system that is flawed in other ways. So you go to a doctor, and the doctor has only 10 minutes or 15 minutes, right? According to the insurance policy and so on. They cannot spend more time with you. That's the amount of time that you spend talking to your doctor, sharing whatever you've learned from the WebMD, and so that's a waste of time, according to the doctor. So if you want to put this into good use, and there is a potential for this, as I said, this is a positive story, then we have to change that system. The insurance policy, should accommodate this. We cannot give people this tool and say, here's this nice, wonderful thing that you can take with you to the doctor, right? And then, kind of kill it in the middle when they are finally with the doctor. So that's, I think, our dilemma at this point. And I think that dilemma actually is working in many of the other places as well.
Okay, we have a question.
Yeah, kind of more of a comment, perhaps unbelievably cynical, but it seems to me that as a social paradigm, you look at things that, technology coming in even back in the 50s and 60s, where television, proliferated throughout the United States and throughout the world. And what most citizens, consumers don't recognize is that the whole reason it even existed at all was to get you to buy crap. And that the fact that it might educate and have some social value was merely a side effect. And I look at Siri and well, even the iPad. It was the perfect consumer portal. You have to buy this proprietary tool to watch the stuff I'm willingly going to pay $800 for you to sell me something just to sell me more stuff. So anyhow, just your thoughts, and my apologies for being cynical, but.
Well, you said it, I didn't. So, but I'm sorry, I just jumped in because I think I share the cynicism that is, but it is, I'm afraid it's more complex than that. It is not just to sell you crap. That's part of the story. There is innovation. There is, there's always this other side, which is, you get good other things with this crap, right? And I'm sorry for the term. You said it again. But let me just leave it at that, because it's really it's a double-edged sword. That's what it is. Let's put it simply. It has that consumerism side and selling stuff and so on. But good things happen, and the sad part of the story is that we cannot decide which one emerges between the two.
Maybe not a brief comment on the comment. Privacy has a price. I don't know what it is, but economists are working on it and trying to figure out how much are you willing to pay to Nazi ads, or how much would you be willing to pay as a subscription flat rate for any social media service, such that ads rate would be lower or more transparent or whatever. So that's also an economic question with plenty of work to be done.
Yeah, but with all due respect to money and to selling stuff, not all innovation comes from the private sector, and not all innovation is for money, or for the sake of buying and selling goods. So there are some spheres of our lives where we should not be sold stuff. Like when I'm on a bus, I should not be listening to advertisement, political or otherwise. And this is something for which there is precedent, right? So again, I think that we as a society, perhaps with the help of regulation, need to come to a point where it's not all about exchanging money for goods and for eyeball minutes.
And one quick follow-up on your follow-up. And of course, once you have a price on these things, that creates all sorts of inequality dynamics, which also would need to be considered.
And this is why I just don't do economics. Yeah.
Okay,
yeah.
good.
My name is Joe Yoon from University of Illinois, and actually the timing of this maybe makes me evil. My background is computational advertising, actually, so I feel a little bit hesitant to speak at this current moment. With that said, so I lead a social media analytics science gateway, as well as I teach social media analytics on campus, and my lab does quite a bit of analyzing social media. And so, you know, I just wanted to throw this kind of anecdotal series of experiences that I ran into as I was going through this, because as I started looking at social media data, analyzing it, you know, looking at machine learned derived data sets from social media, you know, my personal response after I realized all of this was I got off social media. So I stopped posting on social media, all these things, because I thought that's the reasonable response in my mind. What I noticed was when I was teaching this in my undergraduate and graduate classes, and I would say things like, you know, there's a reason why you don't pay for social media, because you are not the customer. We are the products, right? We are, you know, like cattle, right, in a sense. We're being sold. And then I would invite people to write papers of, you know, how they would change their behaviors and et cetera, et cetera. And what I found was most of the students were saying, I have no problem with that. In fact, my problem is I don't like it when the predictions are not accurate enough. And then I have lab members, highly intelligent individuals working in my lab, younger, that know honestly more than me now in machine learning and deep learning and whatnot. And they tell me the same thing. They're like, I'm fully on social media, and again, my issue is it's not customized enough. And so it's when I started realizing, and I'm not saying this is anecdotal, you know, evidence, right? But at the end of the day, it just pointed to me that there clearly is a difference in thinking when it comes to, you know, what is privacy, what is acceptable, what is not acceptable. And it may not be just generational, but I'm also suggesting that even those that are well informed as to what's going on, that they might not necessarily behave in ways that we think they would or should or whatnot behave. So I wanted to throw that comment out there.
Okay, well, thanks for sharing that experience. And certainly true that the willingness to adopt these new technologies goes through the full spectrum of saying, privacy is gone, no more shower curtain, I still can have security, i.e. a lock in front of my house, to the full other end of the spectrum where you want to have a fully private but also fully customized experience, maybe. I hear that sometimes in discussions on social media that people just don't use it anymore. I do social media analytics. I don't really use social media either. But even data that are not there is still valuable information. If certain people don't use that, or if you didn't buy a product or whatever, right? I mean, that's still actionable information that actually can be used as data.
I have a suggestion and a comment. I would ask your dad to talk to these people. But, he might enlighten them. But very quickly, I think that, you know, the real issue is that this is not an option anymore. Well, there's this movement which people call disconnection or disconnectivity. People like, I've never been on social media except LinkedIn. But there are people who just have decided, who are basically migrating out of social media. But it is increasingly difficult because this has not just to do with personal communication. You want to organize a party, or an event, or you want to find a job, or you want to to look for any kind of information or the right type of music, and so on and so forth. These have become kind of part of our daily life, which is we are locked in essentially. I don't know what your experience was, but I think people are finding it very difficult, and so it's not an option so much as it is. It's just there.
And I have to disagree, right? So it is the case that right now and in this country, yes, this information is just there. But this should not be the case. So for example, already the GDPR attempts to go in the direction of, oh, you actually have a say in not where your data is, well, that as well, but most importantly, how your data is used. So we have to have control over that as individuals. So let me give you an example very, very briefly, not from social networks, but once again from the Compass software investigation that was done by ProPublica. How many of you have heard about this or read about this? So very briefly, there is a company called NorthPoint that produces software. The software is black box. We don't know how it works, called Compass. The judges use all over the United States to get recommendations. A recommendation is like an assessment is a number between 1 and 10 about how likely somebody is to commit a crime again, to reoffend. And these are in multiple categories. So there is violent recidivism and just recidivism in any category, right? So this output, this number that is then associated with a defendant and that judges use to decide what the appropriate length of a sentence is for them and whether to release them on bail and how to set bail amounts. This number is derived by the system based on data that the defendants themselves provide. The defendants are waiting to be sentenced, for example, in a cell. They are filling out a questionnaire with questions that are very offensive and very, difficult, like, do you think it's justified to steal when you're hungry is one of the questions. Or how many people in your family have ever been in jail? I mean, this is not a quote, but that's sort of the spirit of the questions, right? Now, so from the point of view of a defendant, giving data of this sort, and they really don't have a choice. They have to give this information. And having it be used to sentence them is terrible, right? But now, an issue here that I want to point out is that this software was actually originally conceived and developed not to punish defendants, but rather to offer them positive interventions. So this is a huge difference, right? So if I were a defendant and my recidivism score were 9, which is very high, it goes up to 10, and the result of that were, oh, here are some counseling services for me, I'd be okay with that. But if the result of this, oh, I don't get released on bail, that's a completely different matter. And this is not something that we should just say, oh, this is how the world is and we give up. We do have a choice, not as individuals right now, but as a society, this is a choice before us. That's just all I want to say. And on social media, likewise, right? I mean, it's just examples are less crisp. This one is just very, very crisp.
We'll do one last question.
So quickly, one comment and one question. The comment is we probably also need to invest more on human psychology, understanding the reactions of humans to more intelligent entities. We certainly, humans, we love things that are transparently convenient. We don't necessarily love the experience of an intelligence of a different order of magnitude. We either are fascinated by it or we are scared by it. That's what, for example, Richard Feynman experienced across his life consistently. People were either fascinated by him or scared, but there was a gap in between. And probably that has to be factored in the design of products and has to be designed within the workflows that lead to the use of these technologies. So for the question, we have many more cyber-physical systems that are controlling human lives. Just Cisco estimated that by 2025, we'll have 80 billion devices with some degree of intelligence. So what are your thoughts with respect to that fact in relation to the need to have verifiable systems that are safe? And also there's a tension with preserving intellectual property. I think that's a strong ethics problem, trying to design something that's safe, but that needs to come out into the market in 6 or 3 months while preserving human lives.
Frankly, I'm not sure if I followed the question. Maybe my colleagues did. Yeah.
Okay.
You might want to reiterate it. Yeah.
Okay, rephrasing it.
To respond, actually, yeah. So there are many ethical challenges. Safety is one of them, right? The complexity of these systems and the ubiquity of these systems is another challenge. So I think that we as a society, once again, need to decide that if safety is something that we prioritize, as it should be, then we don't bring systems to market that are not safe. So we need to be safe, ethical, responsible by design. and to take as long as we need, resisting market pressure, to develop systems that are appropriate for our society. That would be sort of a quick answer. And it's not an afterthought. You can't get a black box system and then make it safe somehow. It needs these considerations at every level need to be embedded into every subcomponent. And this is where computational thinking and abstraction are really helpful, I think, just with respect to these different objectives. Does that, yeah, okay.
Maybe a quick follow-up. Yeah. And a deeper underlying question here is how can we build markets or economic incentives such that ethics, security, safety are not an additional cost factor or a limitation or a hindrance to market entry, but an accelerator of innovation.
Oh, but it will be a cost factor. It's more expensive to be responsible than to just do stuff somehow. I mean, that's a given, right?
Okay. Well, I'd like to thank the panel. This is very interesting. Let's give this panel a round of applause. I think there were a lot of common themes that came out, and we'd like to give you some time to discuss it. Do you want to say a little more about how we're going to go forward?
Thank you. So thank you, everyone. It's fantastic. So we're going to take a break now, actually. So it's time to think about conversation and the panel discussion. Just a couple of housekeeping notes. The poster area downstairs in the atrium is ready to be set up. And then when we come back from break at 4 o'clock, I'll provide the instructions of the conversation time. We're going to call it the breakout, but we're actually all staying here together. We'll gather around the tables. There are a set of questions related to the panel, the role of academia in addressing some of these grand challenges, and also thinking about how the hubs might help to convene or help drive conversation in this space. So when we come back at 4, I'm sorry, at 3 o'clock. Thank you. Sorry. Come back at 3. We'll go through the instructions. They're very simple and questions, and we'll go from there. So enjoy your break. Thank you. Thanks. Thanks very much. Okay, hi, thanks, Matt, hi. Okay, we're going to regroup just for a little while, and then we have one more talk for today, but what we're hoping you might think about for the next 40 minutes or so, or 45, you will see in the center of your table, wherever you're sitting, now there are a couple tables missing materials, and we can get them to you as needs be. But in the center of the tables are some directions that the Hi, I just want to give you a 5 minutes heads up. So if you could start to wrap up what you're doing, your discussion. If you didn't get to all 4 questions, no worries at all. Thank you so much for your engagement. I can tell everybody's either having fun or actually working on the questions, maybe both. In about 5 minutes, we'll start the afternoon plenary talk. Thank you. Okay, thank you. I'd like to invite Bill up to the podium. Thank you, Bill. and we're going to get started with our plenary talk now, after which we'll go downstairs for a wonderful reception and poster session. And thank you all again very much for engaging in these questions and giving us, some real important stakeholder feedback and input for how we move forward. Thank you.
Well, welcome back. Hope you had as interesting a time working through those questions as we did. So it's really my pleasure to introduce someone I've, in fact, known from a long time back in, when I was at Argonne. Dr. Carolina Cruz-Neira is now the director of the Emerging Analytics Center at the University of Arkansas at Little Rock. She's a pioneer in the areas of virtual reality and interactive visualization, having created and deployed a variety of technologies, including the Cave, which is a thing that I remember most when I think I first met her. And that was work that she did as a PhD student. She's recognized as having founded and led very successful virtual reality research centers, such as the Virtual Reality Application Center at Iowa State, the Louisiana Immersive Technologies Enterprise, and now this Emerging Analytics Center. She's received a number of awards, including having been inducted as an ACM Computer Pioneer, received the IEEE Virtual Reality Technical Achievement Award, and the Distinguished Career Award from the International Digital Media and Art Society. I was reminded, because I did know, that this year she was inducted into the National Academy of Engineering. So one of in fact, the highest honor that the U.S. bestows on its engineers. And so with that, I will turn it over to Carolina.
All right. So I know it's been a long day for everybody. So even though this room is kind of very intimidating and imposing, I have a kind of like a potpourri of topics. So please don't feel intimidated. The whole point of these meetings is for all of us to discuss ideas and sort of spark our imagination. So I don't want to lecture. So if I say something that gets everybody's attention, by all means interrupt me. I don't have to go through all my slides. I'm just, chit-chatting on a very imposing podium right now. So I've been the executive director of this Emerging Analytics Center for 4 years. As a little bit of background about me, for reasons beyond my control, my career has been about creating large research centers focused on visualization. So this one is the third one that I know, maybe the last one, who knows? Age is starting to hit me. So, something that has always motivated what I do is something as simple as this picture. What do we see in there? Anything? Nothing. What about now? There is information there. And the only way you can see that information is through visualization. You will probably not find that pattern if you try to look at the numbers. So this very simple illustration has been what has driven most of my professional life. So like I said, on that path, I find myself now in Little Rock. And my center is 4 years old. There was only one other person when I arrived to Arkansas 4 years ago. And we are about 40 people right now in there. So we have a lot of technology, most of it related to visualization, virtual reality, and augmented reality. But most of our focus is on the expertise. Technology, of course, evolve. So our center focuses on the expertise of being able to look at a problem and figure out a visual way to get a solution. We are more applied research than basic research. And because of that, we have the sort of scary word sometimes of deliverables. A lot of the research that we do has tangible, deployable deliverables. And that's something that we are very well known for. And we do deploy sometimes startups, patents, licenses, that kind of thing. We do a lot of that in the center. Buttons? There we go. Because of we all are suffering, we know that nowadays of budgetary stress, our operation is fairly lean. So we are 5 full-time leadership group. Myself, Dirk Reiners, which happens to be my husband, is the chief scientist. Tom Coffin, whom some of you might know because he's a former NCSA, University of Illinois person, manages our operations. Karsten Newman is our senior research scientist and probably the best developer you will ever meet. And Jay Sack is actually our 3D artist, which we stole from the video gaming industry. So what really moves our facility is the rest of the people. So we have a large number of students. We fund anywhere from entry-level freshmen to PhD and postdocs. We also, of course, host many collaborators doing sabbaticals, doing residencies. We have some exchange programs with different universities around the US and also around the world. And we have many affiliated faculty that are starting to be very, very involved and help us with funding. And then we have a very extensive advisory board that are also being very helpful to open a lot of doors for us on a lot of our activities. We do the EAC has 4 primary roles or mandates. So number 1 is, of course, research, but it's applied research. We look at problems that probably other groups don't want to look at because they might be very applied. And of course, in academics, when we do applied research, we all get nervous because that doesn't help us to get promoted. In my particular case, I'm very fortunate at a point in my career that I don't really need any more promotions. I'm a full distinguished, blah, 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 gazillion titles professor, so I can now play. But we do a lot of interesting problems, anywhere from very low-level infrastructure research to the high-level end-user applications. That also comes with the academic component. We have a mandate from the state that a lot of the work that we do on the research somehow translates into the classroom. So we have introduced a number of courses, minors and things like that related to the work that we do at the EAC. Obviously, we are a big recruitment tool, of course, for the campus. We also, our survival depends almost entirely on partnerships. So we do partnerships with other academic groups, but most importantly, we do a lot of partnerships with industry and government organizations. That's very, very critical for our survival. And then finally, all those things come together on our ability to deploy our results out there. And out there can be through open source initiatives, which we have several of those. Out there can be spinning off companies. Out there could be introducing a lot of our results into workflows of the different industry partners that we work with, and many other issues. So that's basically what we do: research, academics, partnerships, and innovation. We really, I guess in a simple terms, we are a software engineering research group focused on visualization. So the thing that really drives us is we call it research with a purpose. So like I said, we like to solve problems, but problems that have a third party will benefit from that solution, and it's an immediate benefit. It's not a long-term, let's figure out how these results help on whatever. It's actually tangible results that somebody walks out of our center with something literally on their pockets that works. And it's actually a lot of fun to see that happening. We are probably one of the most diverse visualization groups right now in the nation. We explore anything from traditional settings like desktop settings, web visualizations, mobile visualizations to, as you can see on these images, much more sophisticated visualization systems. We really like to understand how visual information helps in many environments. So that's why this diversification of platforms is very critical to us. One size doesn't fit all. Now, here is a question that somebody asked me. I was at a think tank 2 weekends ago, and somebody asked me, Carolina, what is your biggest challenge? So I thought I would bring this challenge to you today because I think it's relevant to all the different big data hubs. One of the biggest challenges for somebody like me, that the core of my research is visualization, is actually for our collaborators to understand the value that we bring to the table. Because what happens is we typically come into the projects because we are the eye candy. You know, we made really pretty images that we can show to our sponsors. We made very pretty images that look very good in posters and websites and brochures. But you know, those pretty images are very, very hard sometimes to produce because, you know, it's research. We have to figure out how something looks like. And we don't have any frame of references, so the amount of squishing your brain is probably equivalent to any of you squishing your brain for some mathematical model or some simulation or something like that. Another challenge is that typically when we are collaborators in most of the projects, we tend to be perceived as a service group, not as a partner. And that's very challenging because, again, many times, same as all of us, we don't really know what we're doing. So when somebody says, well, here's my data, visualize it. It's like, well, wait a minute. I have no idea how to visualize this thing. It's not magic. You know, I have to do, you know, equivalent work as you do. Sometimes, and right now we have a project where we're dealing with this at this moment, we're not sometimes considered scientists. We are artists. And yeah, I'm very proud. I have an MFA, a Master in Fine Arts, before I came here, but I also have a PhD in engineering. So yes, I do have a little bit of an artist on me, and a lot of the people in my team have a lot of artists on them. But we are scientific, we do scientific work. So those are things that are very interesting. Of course, we're always the after dinner entertainment. So whenever we host a meeting like this one, you know, you always come and have your cocktail and all that in our facility. And yes, it's a lot of fun because you try head-mounted displays, you try caves, you try domes, you try devices that you have never seen before. You know, but there's a tremendous amount of work that goes behind of that. And we always have to prove our value over and over and over. I cannot tell you how many times I had to answer the question, what do you do? Yes, well, that's what I do. So that has always been a challenge, and any of you here in this room that does visualization, I'm sure you identify with some of these. Now, when we go to industry, the challenge is different. Industry understands the value of visualization, However, now we hit a different challenge. We are academics. So academics don't understand industry. We are slow, we take the money and run away with it, you don't understand anything about quarterly revenues and all those kinds of things, So things of that nature, of course, we just want to publish, so we don't really care about helping this company. I just want something to do that I can write a bunch of papers and then I move on to the next thing. Sometimes, deliverables. I'm a researcher. I don't deliver. Just go hire a consultant and they will give you deliverables. I'll give you my paper, the consultant can implement it, and the consultant will give you the deliverables. We, of course, are going to try to align everything we do with our academic cycles, and God forbid I'm going to work on the summer, because summer is my summer. So industry, I'll see you until May, and then see you later until August, Then, all mine and yours incredibly smart graduate students, when you go to industry, students, little puppies, little thingies over there. Well, wait a minute. My PhD students have already a degree and a master's. And with all due respect, you Mr. Industry person, you don't even have a master's degree. So yes, this person is a student, but is not intellectually a student. It's not a kindergartner. So we deal with a lot of these issues. And then, of course, the most painful of all, you are a professor. Here is my problem. Maybe some class can find the solution to my problem. So sure, of course, right, perfect, thank you very much. So it's a complete different set of challenges that we face. So as you see, my career has been very colorful and very interesting because I'm in between, I don't remember how you say in English, this thing, and I'm just in the middle. But somehow, we managed to survive this. And I think some of these issues, the reason why I mentioned this, I think some of these issues are also being faced by the data hubs. Because, we internally are trying to struggle to figure out what we do as a hub, but also the NSF is trying to figure out what we can really do as a hub, and also industry is trying to figure out what is my value to work with the hub. And it is a struggle. We don't really have a good answer for that. And another little detail that I forgot it was there, when you work with industry, there's all these issues related to confidentiality issues of the information, because of course it's competitive information for them. There are issues related to IP, who owns that. More often these days, I'm starting to see issues related to nationality, as more and more cybersecurity is becoming a huge component of pretty much everything that we do. So that brings me to another issue, another challenge, which is how visualization is being perceived by funding agencies. And since this is an NSF initiative, let's talk just for 2 seconds about NSF and visualization. The National Science Foundation, since the time I was a tiny little, very young student that I didn't even speak English, was putting out there visualization reports and the need for visualization. So here we are almost 30 years later. Oh my God, 30 years later. Did I just say 30 years? Oh my gosh, I'm getting old. Oh. Anyway, so this just, I got it out of the NSF website on the 10 big ideas that is our current sort of mandate. So this initiative supports blah, 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 and then will enable data-driven discovery through visualization. So that's at the top of the report. But now look at this one. When you look at this chart, look at my foot. Tap, 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 tap. What is visualization in there? What is it? Can you see it? I just put a tiny little yellow highlight over there. You can barely see it. So so this has been another challenge and another struggle for people like me, I guess in the last 30 years. You know, somehow visualization is recognized and has value, but at the same time, it's kind of the little thing over there that we all do. So it's on the writing, but it's not in the diagram. It's kind of very confusing sometimes. So that, of course, brings us to the funding. You know, how do we fund what we do with visualization? I have to tell you, with a lot of creativity, because there is not an NSF directorate on visualization. There is not even a program in visualization. Visualization is always this little thing that just has to go on a stealth mode under something else. So that is very, very challenging, because we are always the afterthought of any research project. And I think that hurt us, especially now when we are totally overwhelmed with data. We just cannot handle that data any other way than a visual way. There's just no way to deal with that. So we have to consider visualization one of the key elements as we define our research, as we define our research plan. We start with visualization and we end with visualization. And that, unfortunately, is not happening, and that's why some projects end up not being as successful as they should, because a lot of work is being done, and then in the last minute, people like me come into the project, and we had to struggle to first of all, catch up with what happened in the last 3 years or 5 years, and then actually have to figure out what we got to work with, because by now the results are already there, and we had no say on how those results were produced or stored or computed or anything. Another challenge when we look at funding is a lot of the work that we do is perceived as a tool. It's not perceived as a discipline or as a research theme. And again, that is very challenging, because we do a lot of research. I mean, we have to do a lot of experimentation, a lot of evaluations, a lot of validation, same as any other discipline. I was laughing when I arrived to Arkansas 4 years ago, because when I arrived there, the university was like, well, you know, our idea is to have a visualization center where, you know, scientists come with a USB drive and they'll just visualize their data. And I'm like, oh, okay. I'm not that person then, because I have no idea, you know, how to do this. I just don't, you know. So that was a big heartbreaking moment between me and the upper administration in Arkansas. You know, there is not a general way to visualize anything. I mean, every data is different. Each one of you get your results stored or produced in different manner. So we still have to do a lot of that research, and is highly collaborative. But basically, most of my career, most of my funding for visualization has been always hiding behind some other science that was sort of the end user for our work. You know, I tell to my students all the time, when you work in visualization, it's probably one of the hardest disciplines, because you have to combine a lot of other disciplines. You have to be very good in computer science. You have to be very good in math. In many cases, you have to be very good in simulation, modeling. And also, on top of everything else, if that was not challenging enough, you have to have a little bit of a creative, artistic flair to you. So it's quite challenging to do that. And then on top of that, we also need to figure out how to understand, let's say, the end user application. Now, on the other hand, it's a lot of fun, because we get to do, you know, in my case right now, I have projects that range between helping with visualization on the cybersecurity of the national electrical infrastructure. We have a very large funded project from DOE. Then on the other extreme, I have a project that is funded, it's in the process of being funded by the American Association of Pest Controllers, and anything in the middle. Yes, I say pest controllers, yes, finding roaches and rats and all that. So we go from one thing to the other, which for me is a lot of fun because I really don't have that concentration that many of you have, and I highly admire. My attention span is probably less than a mosquito, so I need variety. So we do all kinds of things across that spectrum, but funding is always extremely challenging. And we're never the focus of the funding. Very rarely we have a proposal where we are the core of that proposal. Now, I bring this to you here in the hub, not to whine or to complain, and again, please feel free to throw some ideas as I'm talking, just to help all of us to realize that there are many aspects to how we collaborate that maybe we don't think are helpful, or they are just kind of like right there, available whenever we want to grab them. There is actually a lot of other groups around us that their work is equivalent or scientific enough that can make us a lot stronger. So what are we doing on visualization research? You know, I survived all these things that I mentioned. I've been doing this for many years. So right now, we are actually in a very good place. Little by little, a lot of the work that myself and other people like myself around the nation is being recognized. And of course, with the, resurgence of technologies like virtual reality and augmented reality, I think most of us are starting to realize that the world is not 2D. The world is not static. A lot of the work that we all do have a lot of variations, a lot of dynamic changes. Also, a lot of the things that we do, we might be moving on a tiny space like the atomic space or the nano space, but the problem is very big, even in that kind of environments. So we really need to move away from that kind of visualizations. I go every year to InfoVis and IEEE-Vis. I'm assuming some of you goes to those events as well. And sometimes I'm a little bit sort of sad to see so much good work in 2 dimensions, but very few research in more than 2 dimensions. And I'm not sure why that is. I don't know what that happens. So I'm trying to focus a lot on looking at, rediscovering the power of visualization beyond 2 dimensions. So that's most of the focus that we have now in the EAC in Arkansas. So for us at this moment, when we look at big data, there we go. We try to be very practical, and we look at data versus information. So, and I'm sure all of you look at that the same way. And, but big data, sometimes people ask us, hey, Carolina, this is not a big data problem because it's only a few gigabytes of data. Yeah, but big data is not necessarily about just the size of your files. You might have a file that is, megabytes, but there are many other things that make it big data, because you might have a relatively small data set or simulation, but it might have a lot of complex relationships in it that are not easily identifiable. We were talking earlier on the table discussion about machine learning, and I'm trying to learn on that myself. I'm not very knowledgeable in that arena, but sometimes there is a lot going on in maybe a small portion of the data, and that makes it big data because there are big problems that need to be solved. in some other cases is the rate of availability. I might have little pieces of data, but they are coming at me very, very, very fast. And I need to process those very quickly as they are coming to me. So we try to do what we call data-driven discovery. And our focus at this moment is just anything that helps somebody else to understand what they're doing, to discover something new, to see something that they couldn't see before. That's basically the work that we do. So all of you are probably very familiar with the big data visualization tools out there. You know, number one most used visualization tool is still Excel, which is like, oh, you know, but it's still the number one visualization tool for big data. Come on, guys. So some of us are also doing things with D3, with, of course, Tableau, which is a commercial package, Google Charts, who knows what other things that we do. But one of the things that we have been sort of realizing in the last maybe 5-6 years is a lot of these tools, even though they call themselves big data visualization tools, if you look at them from an interactive perspective, they are really limited to how much information they can process on the fly. So typically, I would say thousands of data elements, and a data element is very loosely defined as I don't know, a piece of census data or a piece of marketing data or a piece of some simulation results. Most of them are much post-processing, so you do all the work and then you figure out how to visualize those results. So they don't help you guiding to get to those results. And most of them are fairly two-dimensionally oriented. So here is one example that we worked on a few years ago, and a company that I cannot mention approached us and explained us the problem that when they have to make a customer presentation using the tools that I mentioned earlier, in order to give a picture of the data to the customer, they will present somewhere between 200 to 300 charts to the customer. So you tell me what's going to happen to the customer, especially when those customer people are C-level executives sitting through 200 PowerPoint slides that look like this ones. So how many of these things are they going to remember at the end of your 3-hour presentation? How many questions do you think you're answering to your to that customer? You know, and those I just went real fast because again I'm not, and there's a lot more than that. So this was a very real problem with visualization. Big data, because it's information that has to do with patients, it has to do with doctors, it has to do with medication, it has to do with geographical locations, it has to do with regulations. So it is a fairly complex big data problem, and the end result is deciding. It's a marketing problem. Where is this medication going to be deployed in the market? That seems to be a simple question. Do I deploy this in the Midwest? Do I deploy this in the South? Do I deploy this in California? But it takes 200-300 slides to answer that question. And what happens? The question is not answered because halfway through that presentation, one C-level executive says, "Excuse me, I have a question." And they, of course, like always happen, Murphy's Law, is going to ask the question that I don't have a chart to answer that question. So what these kinds of companies, you know what they do? They stop the meeting and said, I'm going to go back to my analysts. We'll, deep dive on the data, and let's reconvene 2 or 3 weeks from now, where I will have one more. Instead of 200, I'll have 201 slides with the answer to your question. Now, how do you do business like that? And that's something that as researchers, sometimes we don't think about it. But how do you do business? You lost your momentum. Your customer might no longer be your customers 2 weeks from now, because perhaps another marketing firm has that 201 slides tomorrow. So they get the marketing campaign of this customer. So this is really serious problems. And of course, all these things happen. This audience is very savvy, so I'll go real fast, because what are we doing these days to do visualization? So first, we are going to gather the data. Some case might take a lot of years. It's going to come from a lot of different sources, anywhere from Excel spreadsheets to literally handwritten pieces of paper, survey results, all kinds of different things. Then we have to make a decision how much of that thing that we actually got we are actually consider as real data for our problem. And then we're starting to make decisions on which data we want and which data we don't want without actually having even looked at it. That right now is very dangerous, because we might be leaving pieces of information out of our problem without even knowing about it. So this is a big source of misinformation and in some cases errors. And we have done quite a lot of work on that, and there's a lot of papers that we have published. Yes, do we publish papers as well? And then, of course, then a little bit of analysis starts. But the analysis starts by trying to figure out what are the right parameters for the visualization. Well, I'm not sure we know what they are. But we made some decisions without even looking at the data. What are the right set of visualizations or charts or images to present to the researchers, to the customers, to whoever it is? And then what is the right order on which the information is given to people? And then finally, after we do all that, then we put that in front of the users. And in most of the cases are fairly static, preset visualizations. And again, sometimes if we don't answer the right question, we had to go back and start on number 1 and go back all again. So obviously, we at the EAC don't think that these kinds of things work anymore. I mean, we generate, again, this community knows that we generate all kinds of data, left and right, and incredible speeds. So we don't want to overwhelm everybody, including our research collaborators. We don't want to spend a lot of time trying to figure out how to get an answer to a question. And most importantly, as we are getting momentum of understanding our own data and starting to find and discover aspects of our problem that we didn't know before, we don't want to lose that momentum, because having to take a step back and again deep dive into something and come back sort of stops that momentum. So one of the things that, of course, we do all the time is trying to figure out methods, algorithms, techniques that allow all that massive amount of data to be readily available for the people that created that data. So we do a lot of work on interactive visualization, and that's where the deep science comes, because we need to understand extremely well what happens between the data and the actual hardware where the data is being rendered. Issues related, of course, to networking, to memory management, all those kinds of things. We do, the other part is, how does this thing looks like? In our lab, we had a big poster that says, "Death to the bar charts." And we're about to add death to the pie charts too. So we're doing a lot of explorations on what these new visual looks have to be, especially using the three-dimensional aspects, because we are really running out of real estate on the screens. 5 minutes, I'm going to go really fast. So we're trying to do all these kinds of things by trying to get advantage of all these new technologies, and that takes me to virtual reality and augmented reality, which is what a lot of people knows that's my work, but this is sort of the logical evolution of how I got to do virtual reality. So the thing that we're doing right now is trying to figure out what is the right visualization platform to represent the problem that we're trying to be helpful with. So with that allows us to do these what-if scenarios, which of course we've been talking about what-ifs for another 30 years in visualization. We want to have a lot of alternatives to explore that data and hopefully improve the discovery process and try to avoid misinterpretations of errors or omissions or out-of-context issues in there. And at the end, basically enhance the work that all of us have to do. So our approach, we are working always very hard to be part of the research team, not the tool provider, so we can work as equals and understand the same kind of things that all of you understand. Interactive, interactive, interactive. I cannot tell you interactive enough, because today, in order to do visualization, it has to be interactive in whichever form. New visual representations, we talk about that. We do a lot of work in new methods on how we manage the data so it can be pumped interactively to you. And then, again, taking that technology. Why am I looping my slide? There we go. So this is one of the few things I can show you. Remember all those 200 charts that I showed you earlier? This is one of the deliverables of the research results. So 200 diagrams are in this visualization. It's embedded on a web browser. I can not go into a lot of detail, but the top left is the entire data set, and the other 5 are some of the clustering that came out of machine learning. But immediately you can see that you are trying to do some marketing. There are certain things that start popping out in there, like maybe you publish an ad in an outdoor magazine. You might be reaching the kind of people that maybe you want, which is, you know, your average mid-30s, mid-40s families with children. If probably there is a population, which is the lower, which one is this left? You know, that's more your widows, your retired people. So I think that population, you know, after my 300 diagrams, I didn't realize I will never reach them. But when I look at this picture, immediately I know that's a population that I don't think is even worth for me to do any efforts to reach them. We have some other visual representations similar to that. But the important thing about this is that this is interactive. All these visualizations are being generated on the fly by the marketing person as he or she is doing the presentation to the C-level people. So if a question comes along, then they can immediately manipulate the tool and answer that question. Now, this is sitting on a web browser, and we're going over the network to the servers where the data resides, and we only bring to the web browser what is needed in the moment. So we are starting to provide these kind of visualizations, but now we run into another problem, is that as we're doing this, now the question is, how do we do this with lots more data points? So we have another project that we've been exploring. There's a company that we work with that with the current visualization tools that they use, they can see approximately 10,000 to 15,000 data elements at interactive rates, okay? But they receive 10 million data points at a time. So if they're only looking at 10,000 points and they receive 10 million, they're looking at, what's that, 1% of their data? So they really cannot use those visualizations for any kind of decision making. So our most recent research has been on figure out how we optimize rendering so we can actually get more information to the screen. So right now, it kind of looks like this, but now we have another problem. Now we have gone from 10,000 data points interactively to about 5 million data points interactively. But now our problem is we have too much data in the screen. So we cannot see it. We can put it on the screen, but we cannot see it. So now that brings us to what is really the fun. And we got 2 more minutes for me to finish. So now really we get into the real fun, because that's when 2D is not enough, because I cannot see all this data. So now I need a much bigger real estate for that data, and probably different types of visual representation. Most importantly, as I have these massive amounts of data, now my data exploration also becomes a social problem, because I probably am not going to look at the data by myself. I'm going to have to look at the data with a team of people, so all of us together are going to have to be part of the discovery process, and that's when we now get beyond the desktop. Now, some of you recognize this picture. So when we look today at three-dimensional visual systems, we go in this direction. So these are the ones, most of you recognize this, I hope, or maybe you recognize this. So the difference between those two rows is actually 30 years of work. Now, there's a body of 3D visualization that has been done on those 30 years that is completely ignored in the popular media, the popular culture, which help us as researchers. So one of the scary parts of what the media is telling us, this is the future. I don't think this works for us. Doesn't work for me as a mother. Any school that tells me that's how my son is going to learn, he is not going to that school, I can tell you that. So to me, this is very unnerving, and I'm going to run a couple of minutes of this over this, because I think this is important for all of us. Because this is what we want, especially as researchers. This is what we want our visualizations to enable us to do. So how do we do that? So my current effort is really trying to understand how these so-called emerging technologies of VR and AR, and we all know they are not emerging, they've been around for 30, 40 years, but they are emerging now again. Trying to figure out how we can use those tools in the area of big data. So there are two possible approaches. You can see a picture where I'm using augmented reality. We're doing multiple projects where scientists, using their own device, they meet together, they see face-to-face, they see body languages, they can point at things together. So that's one aspect of doing it. Most of you, I think, are familiar with the CAVE system. So we continue doing that. We have, right now, we announced it last week at the conference EDUCAUSE. We have redesigned the CAVE to be sort of consumer pro. So there's a new system that is going to be in the market probably in the next couple of months. It's called the CAVE in a Box. So it takes away all the multi-million-dollar expense of buying a cave, the hundreds of thousands of dollars to maintain a cave, and it makes it very, very easy, single machine, no cluster, all that kind of stuff. So we're trying to figure out how do we bring all the knowledge that we have acquired on the last 30 years doing these immersive visualizations to the realm of big data. So here is one of my final points that I want to leave you with, which is something that intrigues me these days, and we call it context-driven collaboration. I do have a military example, and I apologize for that because I know this is not the venue for this kind of work, but it's the one that illustrates the concept the best. All the visualizations are not one size fits all. So depending on who we are in the problem, what our role in the discovery process is, we might need to have a different type of visualization. We might need to have a different type of platform to understand our data. So this is a very easy example to understand. The picture in the movie, in the middle, is your soldier on foot. So for him to understand his data and understand the problem, which is maybe carry on a mission, the visualization platform has to put him embedded in the mission data. And also, in this particular case, it has to give that person the physical feedback of moving through the data. It has to get tired, because as his body gets tired, his mind also gets tired, and his ability to understand the data decreases. The pictures on the left are the commanders, can be your collaborators, can be your subject matter experts. So they have more of a command and control type of operation, and it's more augmented reality. It's the same app. The guys on the lower right are the drone operators. Maybe in your case might be your students that you're teaching them how to interpret data, how to see the problem. And the one on the top right is the high-level decision makers that they need to have an overall view of the problem. It's the same application, it's the same data, but each one of these groups have different responsibilities related to the data. So this is an area that we are spending quite a lot of time right now in the context of big data. Unfortunately, most of our big data problems right now are being funded by industry, and I'm not allowed to show or discuss those projects. I apologize about that. So here's a little one that we're doing for a financial institution related to social media visualization, determine influencers, and so on. So there is quite a lot of data in there, looks very simplistic, and it's very hard to show because it's the interactivity and the immersion that makes sense. So it sounds kind of looks a little funny in there. So just as a parting thought, and I'll be happy to talk during the poster session with any of you that have some questions, we have learned quite a lot through this, I guess, journey that, we really need to make a bigger effort as visualization experts to really be part of the team, and also really pay attention to the technologies as they come. Right now it's a fun time to be in the field that I am, because the technology is affordable, is simple, so all of us can get our hands on it. So it's really the time to be very, very creative. But at the same time, we also work very hard trying to remove that stigma that what we do is a game. It's not a game. It's a multi-million, multi-billion-dollar industry, both research industry as well as commercial industry. Working with industry, I think nowadays is the key for innovation. We all know how tight the traditional sources of funding are. So we also need, and I work quite a lot with different universities, that we need new academics that can understand the bottom line, so we can do our research successfully, but still make our collaborations, especially with industry, successful, that they want to come back and do more work with us. And that, of course, comes with redefine scholarship and promotion and tenure, because that's a very stressful path for some of us that we go and I get an industry grant, and because it's not competitive, doesn't count towards my tenure. What are you talking about? So finally, I think the hubs nowadays are going to be very critical for that progress and that innovation. It's the place where we can all come together and hopefully have this kind of presentation without you throwing raw tomatoes at me. You can all disagree, but at least we can express our ideas freely. We need to know what those collaboration rules are going to be. I think we need to all understand that it's okay as researchers and academics to use the D word, deliverables, and it's beyond a paper. So I think the hub can help changing that culture. Those deliverables include people, well-trained, young professionals that are very aware of all the things that we do in research and how those translate to the workplace. Help us to figure out where the actual IP resides, who owns it, how we transfer it, how we make it useful so we can build on it. Some universities have very tight IP rules, some others so, but that is, at least in my world, is a big issue right now. Help us educate our institutions on metrics of academic success by doing these kinds of things. So competitive funding, what does that mean? Okay, I have a good relationship with company B. This happened to me when I went for tenure many, many years ago. I had a $3 million contract with a private company. And my department chair asked me to remove it from my resume for my P&T review, 1998, because it wasn't competitive. I'm like, wait a minute. It's a different kind of competitive because, yes, I didn't have to compete against 700 other people wanting to get this money, but it was competitive because it was my name that gave me that thing, you know. So anyway, more little details, you know, basically also, and also understand to help us and make industry understand that we are the next people, the next R&D. So we cannot do things that need to be in the market next quarter. So finally, since I see Bill is coming to tell me, this is my final slide. So I think as we look into visualization, I want for all of you to keep this kind of picture in mind. It's coming. Your institutions, one way or another, are going to start having to face this. So with that, this is my team. This is a way to contact me. Thank you. I went about 5-10 minutes over time, but I hope you learned something, and please don't take it as a whining. Just take it as it is. It's, you know, we are a community. We want to be part of the hubs, and we will love to collaborate with many of you, not just me, many other VIS people out there in the world. Thank you. I'm escaping.
From your point of view, you keep referring just to visualization, and one of my collaborators who does visualization always only says viz analytics, visualization analytics. And I wonder if that's some of the transition, like, you know, statisticians have always had this problem that people only invite them after the research is done. Can you fix all my problems? As opposed to involving them in the research. And there's a lot of computation and analysis and analytics in good visualization. It's almost like a culture shift. Do you find that? Does that make sense?
Yeah, that makes a lot of sense, and I think different groups, whatever, you know, as I travel meeting different groups, there are some groups that are, let's say, a little bit more mature, understanding that, you know, whoever is the visualization team is a research team like everybody else, you know. There are some other circles that, you know, they almost close the door, you know, okay, all of us scientists are very busy right now. We'll call you when we need you. So I have to say it's a lot better, obviously, that, you know, when I was a very young professional, you know, 20-something, 30 years ago. But there's a lot of circles where still there is that stigma of pretty pictures, gaming, especially doing, I don't know how to go back. There, especially doing things like that. I mean, this in many circles is not taken seriously. As a quick anecdote, I do have a letter from a company thanking me for doing some visualization in one of these systems because it saved thousands of lives. because they were going to do something on the subsurface that with their traditional tools to understand what they were doing, they would have caused a pretty massive sinkhole. And thousands of people would have died. Through this, they realized that they had to do something in a form differently. So what we do is very important, is very relevant, but still there are communities that, it's just pretty picture. And, without getting political, because I'm also a girl, it's very natural for a girl to do this. In many communities, not here. The NSF research communities are very helpful and very understanding, but in certain industry circles, the girl does the egg candy, and that still has to change.
Thank you. The reception will start downstairs now. Thank you all very much. It's been a great day. We'll start up again tomorrow morning. Hope to see you all there. And enjoy the reception.